Yeah, my name is Gary Tunnicliff. Yeah, that's fine. Um, this is going to be in English, unfortunately for you. I don't speak any or you do, so you can swear at me, absolutely no. So, most of the time now I'm from training, used to do a lot more development. This book consultant, I used to do quite a lot of development. Now, predominantly, I do a lot of training, predominantly in Azure, development in C#. Do a lot of DevOps, similar stuff, and just started getting into Power Apps, which I'm not a fan of. The idea for the 4 hours today is for me to give you a breakdown of the 204, which is the development inside Azure. So I'm going to go through some of the parts in there. There's 4 hours. So I'm going to try not to bore you. But if there's any questions, can you yell at me? Yeah, any questions at all? Because it's going to be really boring for you if I give you this PowerPoint. You know, I'm going to do some demos. Look at what the hack. We'll see how bad the demo goes. And if I screw up, you can tell me. Predominantly, this is going to be looking at some stuff that's specific to Azure. But if you're looking at other cloud providers, AWS or Google, you're going to find very much alike. Predominantly, this first part is looking at web services. And from a development point of view, I'm really going to be looking at the service plan, some of the areas inside their deployment slots and things like that we can use within there. So I'm going to try not to kill you with PowerPoint. So inside here, if I have a look at some serverless applications, the first thing we would normally do with a web application from a design point of view is we're going to look at the service plan. So we would create an app service plan. So app service plans are predominantly everything we do to create something inside the panel. And as you can see here, mine's going to be as free as possible. It's on the listing license, but if we were creating a service plan, this is going to give us the functionality and the hardware that we're going to use inside it. So when you have a service plan, you're going to have different versions. So you've got your free, basic, standard, Windows, and then premium. And one of the things you'll notice about premium now, it's actually less money than some of the other formats. So they're actually trying to get you to use more functionality. And on top of this, we're going to put a web application. But all your pricing for web applications, no matter how you have no applications running at all, are down to service plan. If you look at the features, all the features are to do with the service plan of what you can do inside your application. So web applications, predominantly, the whole of the design goes to the service plan. What features you need and what hardware you want to use inside it. Anyone played with it? How have you found it? Awful, good? I use it for proof of concept. That's all I use it for. So how have you found it?
Well, for a small project where we were a very small team,
Yeah,
having a very small thing in an environment where no one else was doing anything yet.
Right.
So
Yeah.
it worked well for that.
Yeah. I would agree. I use this for proof of concept. Yeah, it's quick. You can do something in an afternoon, show people what it could do, use your deployment slots. But if you're going to do anything else, I'll be using app containers or we'll be looking at something else from a point of view inside there. Again, pay for what you consume. As I said, one of the downsides to this in real life is the fact that if I have multiple instances, I pay for each one of those instances. So this is like starting a new VM. So if I double the scaling in here, that's going to twice the price. If I triple it, I need 3 instances. That's going to be 3 times the price. You say for a small group, that's not that much of a problem. But you start scaling this out, and you're going to find that virtual machines are a lot more cost effective than they would be using this. However, there are some things in here that do work quite well. So you'll see inside here it says stuff like deployment slots or staging slots. So one of the things that's quite nice in here is I could build a full UAT system and have that up quite quickly from a test point of view or DevOps, do a quick run through, point that to a slot and show people that actually working. I can give them a URL so they can change the look and feel, and then put that through into our system. So again, from a proof of concept, this can be quite cost effective. But the plan is what gives you the cost. So this is what the design and the features are all about. So from a brief view of that, I'm going to try not to do too much with this. some of the upsides is the fact that your service plan, you know, depending on what you actually spend in here, can have isolated environments, so you can have ISEs, you can have different environments inside here, you can run production workloads. But I think it's proof of concept, and we'll get this up, small team, we'll get something up quickly. Again, as soon as you're scaling this would scare me from a cost perspective. You know, I think it's quite expensive. You can, however, run multiple apps in the same plan. So try not to. Yeah, I got up early, so I'm not all here. So from a point of this, you know, 3 o'clock this morning I wasn't, I got up, so I'm not too straight on my feet when constantly. But I'll try not to. Wouldn't look good. So from the deployment point of view, this can be fairly quick. It's good to see that some people smile when I was in dark. It's the most smile I've got. So all I have to do is physical damage in the phone. So inside here, with our deployment slots, we can, as I say, use other tools. So if you are looking at DevOps or other systems, you can actually set this up and deploy to them. So you can actually deploy to these systems. If I don't have to start in, let's keep going. I show classic this from a visible point of view because YAML might get it hard to see further from the release pipeline. But if you're looking at stuff like release pipelines, you can actually send this stuff. So you can put stuff inside here. And some of these different slots. So you've got different slots and other things that you can set it up. You know, if you're sending this to different locations, but we can have different slots inside here. So from a design point of view, you can actually create it. So if we're looking at service plans, if I'm using an application, and an application right here, so it's a fairly basic application, has no deployment slots. This is on free at the moment. If I want to change that, I can just change around what the format that is by checking the service plan. I think it'll catch up in a second. So in here, I can just grade whatever this is going to be used to try. So if I look at deployment slots, I can create deployment slot, and I can clone the settings. I could do something like staging. So and I can add a deployment slot, look at traffic management, pass this URL to other people. As I say, from an application design point of view, I might want to put colors, fonts, that kind of stuff up there. That's quick. So I can set that up. What's coming up? The other thing I want to look at in here is, say, something like identity and also authentication. So in here, I've got staging. Staging is now using a URL, a new URL, staging at the end. If I look at the original, I'll have two in here, and that's using the name of the project. I might have nothing in here actually, but the other one is going to be using the name of the application. So HTTP API gas, it's a Docker application, it's just HTTP code, HTTP codes. Second one, hopefully. When you block and you come up, not 2 hours later. Do something. Okay. Well, that's coming up. If I look at authentication, we can have different providers do this. So this is currently a set up Microsoft provider. But but we can add other providers to this. So I can use Apple, I use Facebook, Google, key writer of OpenID Connect format as well. So there's quite a few different settings inside from authentication point of view. And the other side to this is the fact that this integrates with Entra ID. So our identity plane here is really going to be using users, groups, applications, and devices. That in case mine. So inside here, applications, one of the things we can do inside here is register some applications. So it's going to be a logo required. So we can create new applications. We can make these a service principal. So with our applications, we can set up authentication, and every time you create a web application, it's public facing. Okay. And then we've got any questions on this? Or I'm boring you to death. Because you won't look to death. Do I have to fall down again? Yeah, so from a web application point of view, is everyone happy with web application? Yeah, I'm assuming you are. We'll look later. So everyone's happy with web application. So the downside to something like Azure then, the biggest downside I can see is cost. So normally from a design perspective, we have things that are based on cost and performance. So cost performance is normally the criteria we're going to use whether or not it's worth actually creating anything. And that's normally what we would use. If it's going to cost me more to have a web application and it's a VM, I'm going to use a VM, even though it's not admin overhead. You know, just because it's a platform doesn't mean it's going to fit. If I'm looking at serverless, there might be some advantages to that, but the downside to serverless is it doesn't fit in all those areas. And I also don't want to have serverless where I'm paying for it all the time, as if it was on all the time, because then that's going to be as costly as if I'm running a VM. It's not having much administration. So inside here, the main thing, as I say, from a web application point of view, I'd look at, certainly if you're going to take the exam, is going to be something like the service plan, and on the top of this, we can have blocks and authentication inside here. The other thing with applications, 2 hours later, is from our applications, or not all, maybe, I can set these up. So if I do set these up with my authentication, when I do an app registration, so if I create an application, and I register it, what I'm going to look at in here is going to be your client ID, application ID, tenancy, and also secrets or certificates. So this is what we're going to be creating inside here. So if I want to use this, we create a certificate for a certain period of time, and those are the things we're going to use from a security point of view. So that will create our application. That's our service principal, and we can authenticate into that and use it. We've got other formats inside here where we can use permissions as well. So we can do some back-end stuff where we're looking at delegate permissions and also looking at application permissions. So we can do things under the applications identity, or we can do things with the union of beside the user and what we set up on the application. So this will be least privileges based on who's signed in. And a lot of 365 stuff works this way. If we're looking at, I'm going to finish this fairly quickly because I like you see a wait. Does anyone play around with static websites? Blazor, Angular, yeah, those kind of things. Anyone playing around with those? Looks good. Yeah. Do you think there's an advantage for that inside something like a cloud-based system? And a disadvantage?
I mean, it works for us. I don't know. It's a lot of configuration for.
So normally, if I'm going to run this, I'm going to run this from a storage account. So from a client-side point of view, I can run this. So I can have my static website. So I've got a static website in here. So this is the storage and the settings. This will have change of this static. So I've created a static website under here. It's not a couple, but it's a static website. I can look at this information. make sure I put cross origins in, because I've got some cross origin stuff in there. But I can use this, and this is just going to be a basic Blazor app. So this can authenticate user things. So if I'm getting claims in other formats, it's going to be asking to authenticate myself. And obviously, what I'm doing inside there. So for a static website, we can use that. There are some downsides though. So the other thing in here, I have this under CDN. So I've got this under a CDN, it's a slightly different one. But I've got a CDN in here, so I've got a static website, it's under a CDN. The upside to this, it's going to cost me pennies. You know, I can put a custom settings inside this and use it. I can also call functions. So in this case, I can set some local there, but I can also call a function. And this is just a hello world function. But from our point of view, what's the upside to a static website? If I'm using storage, what's going to be the upside to a static website? How much do you think it's going to cost me to put something to store it? If I put gigabytes, how much do you think it's going to cost me? So one stab in the dark, how much do you think it'll cost if we look at storage?
Very little.
Sorry, very little. Yes, yeah, pennies. Okay, so from my point of view, it's going to be pennies. If I look at some of my storage, which is where this is located, go under my storage and look at cost management. Cost analysis on here should be pennies. I'm going to pay more for a WAF. I'm going to pay for, you know, those kind of things that I can talk to. The other downside to it is security, where you can run this, where it's hosted. Are you allowed to put it on every edge server globally? Yeah, because that's where it would put this. And that would be one of the issues you might have. You know, so I pay more in using a Vault and looking at other systems than I do using storage. But from a hosting point of view, if you're looking at £30 cheapest for an instance, you know, looking at this, it's going to be fairly cheap. And if I'm pulling functions, you know, so if I'm pulling functions inside here in consumption model, I get 1 million of those 3 months. Yeah, and they can use 400,000 gigabytes per second. So they have a fair amount of usage inside there. So if we're using static websites, these can be cost effective. I can post things. It's going to cost me very low. I can get my dynamic stuff out of functions and my static stuff out of storage. 90% of most websites are going to be static. They're going to sit there. Yeah. So we can use this. As I say, the downside to it is going to be security. And if you're allowed to host things inside those locations, we can run them from on-premise. I can do static websites and just host them from on-premise and push them into those systems. This is using WASM. This is a client-side Blazor. So that can be quite useful. But the other things inside here calling a function. So the other side to this would really function. What's going to be the problem if I call a function normally? Anyone playing around with functions? Or lambda expressions or whatever else you get. What's the upside, the downside to that with, say, a consumption model?
Pay as you go.
Sorry?
You pay as you go.
So that's an upside, hopefully, yeah? Or you don't pay anything until a certain amount has been reached, yeah. So what's the downside then with, say, consumption model normally?
It can be really costly.
No, hopefully pay as you go is quite good. Yeah, so if we don't use 100% kind of things, we're going to keep most of the systems, but it could be an argument, yeah, to over a certain percentage, 50% or something, might be very expensive. What about cold starts? If I look at consumption model in most, Lambdas, AWS, they had loads of problems when we first started out with these. The same thing is in Azure. So when we first started up, this is a hello world. You know, all this is a HTTP trigger, it's hello world. But inside here, the downside, so this is an HTTP trigger that says, you know, hello world. So this is what it's called from Blazor, you know. Okay, the API calls succeeding kind of thing, hello world back. So the downside to this function, though, is if I don't have something on it, it's going to take 7 seconds to start.
That's a really slow function.
Sorry?
That's a really slow function. It should not take 7 seconds to start.
Agreed. So how can we stop that? Yeah. You could also just have an application that pinged it. But one of the things inside this, the reason it's taken half a second is inside this function, there is actually just a ping line. So underneath this function, from a usage point of view, And they've changed all the settings in here, but under Application Insights, under Availability, there's just a ping on it. So inside here, you can just start this up, hopefully a lot quicker. So from a point of view inside here, holy God. Let's change every single thing on the left-hand side. So there's a ping that just keeps this alive. Okay. So you can have your consumption models, and you can pay as you go, or you get 1 million free a month, and you can use those. So from a function point of view, this could be quite useful. If I can put my data statically, 90% of it, have dynamic stuff with functions, that's a good thing. So what's the downside to this kind of thing besides security then? Why is this a bad idea? Why isn't everyone doing this?
I assume you have limits, so you're not vulnerable for DDoS attacks that will.
So from a static point of view, you could use front door and stop all your, those are denial of service attacks, yeah, so we can do that. It's static data anyway, predominantly, so it really doesn't matter, but you can cache it so you wouldn't get hit with that, yeah. Can anyone see any other downsides? Why isn't this done all the time? Well, the big problem is still where you host this. Yeah, we've got regulatory problems. You know, where is this being hosted? You can't have this on all edge servers, so I'm not using CDNs with it. It's in a storage account. Yeah, so yes, I can do this, but it's going to be in some location that's specific to where we do it. And normally, we're going to go maybe from on-premise into the cloud and use it as a shared service to actually get to that, rather than a hosted public-facing service, especially if I've got regulatory issues that say where you can host things, you know, in Europe. So that's one of the downsides to that. It's gotten really quiet again. Do I have to fall over? Yeah, yeah. Okay, so from a configuration point of view, they're fairly easy to configure. One of the things I'm going to do in this, go on, please.
Pinging the function regularly, is that the intended way to use that, or is that just?
I haven't found a downside to it. It hasn't cost me any money, so I think that's a good thing. Is it a good use of that facility? Is that what we're saying?
Kind of. It seems like an issue that Microsoft should.
Agreed. Yeah. Yeah. They should have built that stuff in. Yeah. Yeah. But I haven't seen any cost downsides to it. And the only thing I'd look at as a downside would be if I'm getting hit with costs. You know, it doesn't even come up as a cost. So I'd see that as a downside. Yeah. If Microsoft were going to say, you know, you're using ping all the time, it's hot, then we're going to charge you. You're not using premium functions for the same functionality, and that's a downside. Yeah, because the other difference inside our functions is, I'll talk about it again, but we've got our consumption model, we've got our premium, and we've got the same as if we had an application where it's on all the time. So one of the downsides of applications is we don't turn them off. So one of the things inside here that I'm going to talk about, I was going to use a bit later, was is going to be a function. Let's just cancel that. Is going to be a function. So inside here, somewhere on infrastructure, I'm just going to open this in VS Code. Cancel that. I just want to start up VS Code, thanks. So one of the things inside here I would use quite a lot is Terraform. So inside here, I'm going to do a demo later on with this, but anyone using Terraform? Yeah. Good or bad? Yeah. Any good sides to it? It's behind maybe what the other native people are doing. It's cloud agnostic. We could put comments in there. I think it's quite easy to use. Did this in a couple of hours. It wasn't hard to actually understand. It's a lot better than ARM templates when this first came out. Bicep's a little better, but I've still got issues with that. But from a point of using this, I think this is quite nice. The one downside is it's going to be behind the curve because it's going to be behind whatever Microsoft changes are doing. Same thing with AWS, same thing with Google. Yeah, and I've got to think about the providers and the other stuff that's going to go inside here. But from a Terraform point of view, infrastructure as code, I actually quite like this, certainly as a developer. The fact that I can name these things, resource groups, storage accounts, containers for storage accounts, service plans, identity. So this is the identity and some settings inside here you can't read. Service plans, setting up Cosmos, and then setting stuff up in a key vault, and then just putting some values inside there. Yeah, so using the key vault and setting some of the stuff inside it. So there's a couple of functions. So this Terraform file is what actually does that serverless setting. So the idea behind that is that we can set that up from a DevOps point of view and just deploy it. So from a point of view of configuring all these settings, I can set these up, deploy them in Terraform, put it through DevOps, do whatever I want to do, then deploy our functions or our other settings or our applications and get that into Azure. It's normally about 5 times faster than if I did it any other way. So infrastructure as code is still by far the best way to actually talk to the cloud and using those kind of settings. So from an overall point of view, you know, we can have different ways of looking at this, but I'm not a fan of web applications, I think, from a cost, but I'm certainly a fan of static. And if WASM ever comes out properly, I'll be a fan of that. So from an Azure point of view, though, and looking at the 204, the idea behind here is this is going to sit around, you know, looking at scaling and other issues inside here. And probably the downside, as I say, with scaling, or the biggest problem with scaling, is the fact that you're going to pay per instance that you bring up. So we need elasticity. So we only have this scaled up when it's needed, and we scale it down so we won't pay as much. Okay, so from that point of view, it's actually cost effective, hopefully. Okay. Anyone you like Azure? Because I know this is the afternoon kind of thing, but 2 people, that's not that good. Yeah, 2 people out of 40. Yeah, so from a heat point of view, this was a good one to go with. Yeah. So from a Microsoft product, one of the definite things I'd say with Azure is it's always been about 2 years behind AWS in a lot of instances. They won a lot of the battles with, say, 365, but a lot of the other service stuff, if they hadn't bought fresh foods, they wouldn't have lost as many customers as they did, certainly in the UK. But from a design point of view, I think most of their stuff, it was 5, it's now about 2 years ahead. But they have made some changes there. From a development point of view, though, you know, if you have a lot of the stuff that we look at with AWS, if you're looking at Java, it might be good from a Linux point of view. But if you look at a lot of other formats, you know, they've taken a lot of time to move that over. And they don't have anything like 365, and Google doesn't have anything that's like hybrid or going to have anything that's enterprise-based. So that's other areas they're not going to meet those criteria. If you're looking at scaling, my biggest problem, as I say, inside here is you've got to look at cost performance. So one of the problems with app services is going to be cost performance, and you're going to have to think about that. I'm going to try and keep everyone awake. So the other part we're going to look to this is, say, that I've just talked about is, say, functions. So I'm going to do a brief overview of some of these things. Hopefully, in about an hour and a bit, you're going to have some food, so you'll be happy again. So up till then. So I'll try and keep you awake till then. So if we're looking at functions, one of the cool type things for functions is they've got no user interface. So we're looking at bindings and we're looking at triggers, really. So we want input and output, and we want to be able to trigger things. So the nice thing for this is the fact that we can have these, we can route them, we can actually use event sourcing, we've got things that can connect with the data sources, and we've got storage that can be used within here. So one of the things we have in Azure, if we're looking at, say, storage, is we've got events. So one of the nice things inside here is that we have a publish-subscribe model built into our environment. So if I want to add this to a queue and put a service bus on there, I can just add a subscriber and point that to a service bus, and that will start getting queued messages from everything I've set in there. Yeah, so I can actually extend this quite easily. And that's quite quick to do. I haven't done a lot of logic, and as a developer, I've done not much. I've just added a new subscriber that's actually doing that, and that can be then pulled from another queue. So I can set this up fairly quickly. The other thing with the queuing stuff inside here, depending on what we're actually using, depends what events they put inside there. So we can write things based on new instances coming in here and start to process stuff. Yeah, essentially in here, you put in what it is and then point it to an endpoint. So we can actually create this. So if I'm doing stuff in a web application where I want to resize the image and all those kind of things, they can be done fairly simply. If I'm looking at doing other more complex stuff, I can actually route these as well. So inside here, I could use these and push them around to quite a lot of different systems. We've also got some filtering stuff inside here. So they've added this where we've got more advanced filters where you can use different operators inside here, and you've got dead letter queuing inside here and things like that, which I'm not sure that I'm a fan of for events, but they've got them in here. So if the events don't start up or they're too slow, you can have a look at those and use dead lettering and get them in a storage account. You can also do retry policies and look at other event subscriptions. So from an event point of view, we can have those being fired, and we can have a lot of logic being put into our functions, in this case, if I'm writing functions. So based on this, any subscription, go on.
Yeah, my question, but when you're talking about functions,
yeah,
you have choices what you want to implement it, and is it Python, Java thing?
Yeah, different types. Yeah. Yeah, so you got different languages. Yeah. Predominantly at the start, it was more JavaScript and TypeScript, but in C#, as you might expect, it's a Microsoft product. But now you've got Go. I think you've got Go, you've got Java, you've got quite a few others now as well. So yeah, you can write them in, certainly in Python. So any of those languages you wanted to use. And again, if you're looking at VS Code, you've got the template and all that kind of stuff inside there that will do that. All right. Anyone using VS Code, or do you all hate that as well? Oh my God, it's nearly 30%. That's kind of scary. Yeah. But it's nothing to do with Microsoft, so it doesn't matter. So from a point of using the cloud, though, VS Code is quite nice because it's quite light, compared to, say, Visual Studio and those other things inside here. So when we're creating functions, though, there's a lot of functionality in there. So if we are triggering these, we can say how they're going to be used. So if we are designing them, you could do basic HTTP triggers, but we can all do other things with, say, event triggers. So one of the things inside here, I'm going to look at a bit later, and we'll see how wrong it goes, is the hack where you actually do look at something like a license plate format. So I'm going to look at serverless stuff inside here. There's a challenge, but the idea behind this is it actually does create some information based on this kind of format. So I'll do a demo with this a bit later on, where you do have storage blobs, and you've used an event grid, which is going to route or filter. We're using OCR reading, so you can do this with labels as well as, say, car number plates, which this has been written for. You can actually pick this up, add stuff to the key vault, use application insights, and success or failure can send stuff to different containers in Cosmos. And then if it can't read it, you'll send an email message and populate that with a list of things that can't work inside there. So it uses a fair amount of the different formats in there. So we'll see how that goes a bit later. So functions are an integral part for this. And if we are writing this serverless, the fact that I'm getting a million of these for a month, and I'm actually only consuming what they're actually doing. So in this case, it might be just passing a bit of JSON around, which is all this really does. So we're putting this into a Cosmos database, or I could be using this with, say, SendGrid or Twilio, or I could be putting this into a queue. These kind of things can be easy to actually add together. So functions sound good. So what's the downside, do you think, to functions? Why do companies go bust if they write things as serverless only? Because quite a few have. Just go to Dublin and have a look at a couple. What's the downside to serverless as a design parody? Anyone using serverless? Have you used it as a part of a project rather than the whole project, though? How do you get your data inside to the cloud kind of format? How are you putting the stuff in? Are we using a web front end where people are submitting? Are we actually having them going over a data factory? Are you putting in things in a queue? How are they actually getting stuff into the cloud that you're then kicking off? Because a lot of the problems with functions is how do we start this stuff off? You know, and the design when you're doing these functions has to think about how they're going to scale. You know, well, Microsoft consumption model scale, we can pay some. It'll run for an hour if you pay for premium. You can go across secure networks. You can write it so you're doing on-premise with your own customer data and put it inside the cloud, so that will work. But the downside of this normally is how do we get stuff into the cloud in the first place, securely? Yeah, how am I writing stuff in there? If I give you a front end and you're sending emails to me, like Amazon, you're buying stuff, great. But how do we process that so we're actually running that as a serverless mechanism? Because I think that's one of the design issues you've got to think about this. These work in great areas. I'm doing labeling. We've got 10,000 documents we want to label and changing that. This works great. You know, I can kick them on from an internal service point of view. We're checking camera number plates. Great. I've got somewhere where I can process that. My big problem is still how do I get that into Azure in the first place securely? Probably a service bus, queue it, so I can get that in. And then this can kick off when that event fires. It's a subscription model. But the downside for me for serverless normally is how do we kick this stuff off? What's the design issue for when that's designing? And how are we going to start triggering these things to work? And if it's loosely coupled, which is what we want, if something breaks, I still want to be able to continue accepting stuff from clients and then kick this off again when we fix some of those areas. Yeah, so there are some design formats inside that make sense if I'm using queues. So, but most of this is going to be a sort of trigger that kicks these off. The other thing is what happens when we get a bulk throw of stuff and it doesn't trigger fast enough on a consumption model. And you do get that. Yeah, it's one of those things where even if you don't have cold starts and everything's running hot, you got loads of 429s maybe that are going to give you the problem inside here. Yeah, that's why they put dead lettering queuing and those kind of things in, because that's how everyone was using it. So the design of this is still something you've got to think about. And caching and queuing makes a big impact to how well these are going to work. Yeah. So normally whenever you're designing anything with functions, you're going to have something as a queue somewhere in there as well. So you've got a buffer if things go wrong.
Excuse me?
Yeah.
What is the difference between a web application and serverless? I thought serverless was some kind of web application.
So say that again for me. What's the difference between web applications and functions?
No, and serverless. I thought web application
So web applications are classed as a platform. Okay. Yeah, and serverless is actually classed as function as a service. So you pay for what you consume. If I have a web application and that has to run on a service plan, yeah, I can't turn that off. I can't turn off a web application. Even if I have no applications running, I'm still going to pay for that on that service plan. Okay. Functions, I only pay for when these consume. If I use a consumption model, I can actually put functions on and make them exactly the same as a web application by putting them on a service plan. But if I'm using it as a consumption model, I only pay for them when they're consumed. That is more serverless. Okay, so web application is treated as a platform and we're hosting it on a service plan. And serverless is really, we're triggering this, we're using some resources and we're going to pay for those services until they finish.
And can I ask, what is a VM? Because
so a virtual machine is really classed as infrastructure as service. So if I have an on-premise environment and I have virtual machines and I want to just lift and shift them and put them into the cloud, I can just take those VMs, replace what's in them and put them into VMs inside the cloud, and I can use those as an infrastructure as a service kind of mechanism where I still administrate them, and the cost of that is going to be normally 2 to 3 times what I pay for on-premise. Yeah, cool.
I guess that I can run VMs, I can run Kubernetes.
Yep.
I can run functions in Azure, right?
Yep. Yep. You can also run your container apps that run on top of Kubernetes, but again, you only pay for what you consume. Okay? So it's a serverless model. Container apps are a serverless model inside Azure, but they run on top of Kubernetes. So I used to have to create Kubernetes clusters and put my containers on top. Inside now, if I look at container apps, I can create container apps. And container apps underneath will have Kubernetes running. So they put this into a pod for me. So I can create my container app.
Do these run on Azure Kubernetes service, or is it something else?
So are these running on?
Azure Kubernetes.
So these will have underneath them a full data system. So this runs on top of Kubernetes, but I don't control it.
So you don't control it.
There's nothing I do. All I do is I pay for the consumption on top of their services. So this is a cheap, really cheap mechanism of using Docker, especially if you're using it as pay for what you use. Yeah. But you get Dapper and a lot of other functionalities inside there that make this worthwhile. So this kind of thing is where it's more cost effective, but you've still got to think. So if you are looking at container apps, you're still going to have to think. So inside here, so these are some of the settings you'll see inside here. So you can have a look at ingress settings. You've got Dapper, identity, but you've also got stuff like scaling. So you can scale up to whatever settings are in here. So you can scale these up to 1,000 instances. So you can do a lot of the functionality in here without me creating the Kubernetes cluster and paying for that underneath. So this can be cost effective. So you can do your own tests inside there, but it's cost effective for a lot of those areas. I'm quite a fan of container apps, certainly compared to ACIs, which I think are worthless. So container instances I just find useless. So going back to the point, though, of how we design these things, if we're looking at, and I apologize, if we look at infrastructure as code, the downside to infrastructure as code is normally the fact that you're going to have to administrate it. So if you're looking at VMs, the downside argument was the fact that you're administrating it. And if all you do is lift and shift and don't re-architect, it's going to cost you 2 to 3 times what you'd pay on premise. Where we used to use a capacity plan, we pay it over 2 years and 3 years were free. So a 5-year plan, we didn't do an overhaul of hardware for 5 years. So when I used to do projects, we had a 5-year plan, we pay off in 2 years, 3 years free, and that was a fairly cost-effective way of designing that. If you look at any cloud providers, though, they're all going to be a rental model. So you're paying for them all the time. So not only do you have to pay for administration, you're also paying for the resources. Okay. So virtual machines are not normally a good way to go and use the cloud. So where would they be useful?
Would you use a specific product that's not containerized naturally? For example, Click.
Yeah, legacy stuff as well. Yeah, so legacy stuff and those kind of things are still going to fit in there quite nice. And there's still loads of companies that will have to use VMs for the next 5 years. Yet the bigger the company, the worse that kind of movement is going to be. If you're a small company or a medium-sized company with 365, you could change over a lot of those systems, it's going to be quicker. If you're a large company, you're like any boat, take half a mile to turn around, it's going to be a lot worse. And VMs can still be used there for a lot of the applications. Also, if you're using old Windows applications, do not write containers, put them into VMs. They're going to be a lot more cost-effective for you. Yeah, if you've ever seen how bad Windows containers are, you don't want to use them. So infrastructure as code, platform as a service. So platform as a service is going to be our web applications. Databases, we can use databases as a platform. So you can have a single database inside here and SQL and run that. Do we think SQL is a good thing to use in the cloud? See, these are sweeping statements, aren't they? Keeping you awake, though. Go on. Don't put your hand up, just yell at me, it's fine.
Sure. From my own experience.
Yeah.
Postgres as a service.
Yeah.
Of course, it was SQL. I didn't detect any problems at all. It was wonderful.
Let's not go too far. Wonderful and Azure. I thought you hated it. Yeah, wonderful. But from a single database point of view, or Postgres, or using them as an endpoint, I think they're quite, you know, they can be cost effective and they can be quite good. Were you in multiple locations? Did you need multi-write databases? Did you put anything across WANs? No. So that's why they were good. Yeah. So relational databases are great if you're looking at them as if they're the same as the enterprise. You know, if I want something that's going to sit in Oslo and I want something that's going to sit in, you know, Sydney, do you think SQL is going to be a good way to go? Well, we did a SharePoint project, I don't know, 15 years ago, and we put something in Cambridge and something in Orlando. And there were more people in Cambridge, so it was actually housed there. And then people in, when they were in Orlando, had to wait 5 minutes before they logged off their boxes, because that was writing the data asynchronously. And we had to hope that was even being written. We had to do tests to see if that was even being written. So SQL is great, or relational databases are great if you've got them in the same area and they're treating them like the enterprise. The other side with SQL, though, is how much experience does everyone have with SQL? If I have someone that comes from university, how many of those graduates will have some knowledge of SQL? You know, no matter how bad it is, they've got some knowledge of it. And if I have 98% of graduates, what would you use a back end to an application? I bet, you know, 98% would say SQL. How many people think SQL's a good back end for most applications? Certainly in the cloud now. Do you think it's still a good one? With your web application knowledge, you still think SQL's a good back-end data source? So if I'm looking at ORMs, I'm looking at EDMs, I'm doing data modeling kind of formats in there, do you still think that's good? Could I use Redis? Could I use other kind of databases inside there? Certainly from a web application point of view using JSON, I've got other things inside there now I can use. Yes, certainly how easy that is to set up in a lot of applications. And if I want to go multi-cloud, it's going to be a lot easier. The only good SQL I've seen that works in the cloud is Spanner. And that's because every Google server has, what is it, actor time or whatever they call it, true time, that's actually running on there so you can get transactions working across the wire. That's the only one I've seen that even works like that. So if I'm looking at other things, we're having different kinds of mechanisms in there to do that task. So from a point of something like a platform, I think it works well if you're treating it as almost the enterprise. And if we're looking at function as a service, which is the serverless side, then I think, you know, functions and, as I say, container apps are actually quite nice if you pay for what you consume. So what's the downside to that, though? As there always is. How many people are going to host front ends, you think, in your container apps or your functions? Would you be able to do that? Well, your functions have no front end. You have to trigger them with something, HTTP trigger, or you're going to use some other service or subscription or some kind of to kick them off. And if we're looking at container apps, what's the upside of me hosting that 100% of the time to host stuff? Well, I'd have to work out the cost if it's better than, say, something like a web app. And certainly it's going to be a lot worse than a static app. And if we're using cost and performance as the main way to do that, it's a terrible idea. Yeah. So every one of these will fit in certain areas. Yeah, as I say, static is great, but from a security point of view, you're going to find a lot of companies you can't use it. So that's going to be a downside. Container apps, I think, are fantastic in respect to the fact you can use a lot of functionality in there and you pay for what you consume. So functions have really got no front end. We're going to trigger them, and we're going to have input and output bindings. Yeah, so we've got input and output bindings. So really, that's what this is going to use as a function. Anyone come across logic apps? Anyone see 365 Flow? Yeah, that'll tell you really what that is. Yeah, so the old consumption model. Anyone like 365? Because almost nonchalant, it's none effect at all, so nobody's even seen it kind of thing. All right, so from a logic app point of view, inside Azure, declarative logic apps, nice, be good if I could see, nearly left. So inside here, this is going to be our flows or Power Automate or whatever they call it now. But this is a declarative format where you really write flows. Yeah, that's really how that's coming in. Well, one of the things they changed logic apps as well now. So logic apps used to be, and I should have one up here, yeah, so I've still got an old one up here. So logic apps were where you could design some kind of logic flow. So this is a workflow mechanism where you can do a basic trigger. So these are very much like your kind of functions there. I can connect this to some like a service bus. I can have a trigger inside this based on really, or maybe I can't. When a message is coming in, so inside here, I'll have some kind of queue, and I've got some messages when they come into this queue. It polls for, a minute and then throws it somewhere else. So I can kick this off as a logic app, very much like I can off in a function. So when we've got a function, we can kick that off. If I'm looking at other logic apps out now, so we have other logic apps which are called standard. So we have standard logic apps. Now this is a full whenever it catches up. This will be a full workflow system. Or not, as the case may be. It definitely doesn't like thin lines. Yeah, so inside here, we can have a workflow system. So this is really the replacement for BizTalk. Okay, so this is now a full middleware kind of product that's being put into Azure. So we can have a app service environment. So this is isolated, fully dedicated. It's got a VNet. You can have a full flow system in here. You can write all your workflow, and this will be, hundreds of pounds or hundreds of kroner or thousands of kroner inside here to actually get that running. This will be consumption, so you'll pay for this when you use it. It's shared, and it's pay per operation. This is dedicated services where you're actually going to be using this. And this is a workflow system. And if you use this with, say, integration services, this will allow you to create maps, schemas. As I say, this is, for all intents and purposes, what I used to do a lot of. So this is BizTalk, or not, as the case may be. So inside here, we can write middleware and have that integrated with those systems. So this will integrate with those third-party systems, and you can use schemas, XSDs and those kind of things when you're passing information in here. So this will allow you to write middleware and partners and other settings inside there, and you can map those to logic apps. So there's two parts to logic apps now. Logic apps, workflow, and functions, which are really code-based, so imperative. So workflow you use a lot inside 365, and you can use it a bit inside Azure if you want something that just polls. If we want functions, I normally want to have them running on events. So I want a publish subscribe model. And this is going to be where your triggers come in on why that's going to fire. You can also debug that locally. So in there, whereas inside your logic apps, you've really got this just with the log analytics.
Just a quick question.
Go on.
You say 365 all the time. Do you mean Microsoft 365?
Yeah.
Office, which is...
Well, Microsoft 365 is their office tools, but it's also security. So ESM and that kind of stuff is inside there as well. So from a product point of view, 365 is how I call it because I deal with it that much. But yeah, 365 is really all those tools. So it's the office tools, but it's also the development environment in there. Because if you look at their Power Platform, they've pushed that as the whole of their 365 now. So Power Automate and that kind of stuff. So go on.
Yeah, there was one time ago where Sharp and Microsoft tool. There was something called Windows Workflow.
That's what you're writing this. That's how bad that is, by the way. Yeah. They were going to come out with Orca about 10 years ago to make it so we could design that stuff, but we still got to go to WWF. But they got done for trademarks, so it's called something else. I can't remember what it's called now. Workflow.
Because there was like a time ago in Norway where there was this sort of popular pattern like ruling. So this is sort of
still the same. Yeah, that's all that kind of stuff inside there. And this goes back to sagas and that kind of things. So if you're back to BizTalk, there were sagas, which is your rule engine you're talking about. So yes, all that's still in there. Yeah, and if you are using the standard version of Logic Apps, all that stuff is in there. Okay, but you're going to be paying a fair amount of money for that just as a dedicated piece of software. So if you're looking at middleware, it's a good way to go because I can call all of the 365 stuff, but I can call any APIs or anything else inside there. It'll integrate with it. We can use correlation IDs. We can have things that are synchronized so they can go to a data source, store for 3 hours, and then when the next message comes back in, start up again. So hydrate and dehydrate, that kind of stuff. So you can do all those kind of things in the standard logic apps. So that's the middleware side that they're doing. Yeah, but BizTalk dies, I think, next year from an on-premise point of view. So by 27, there won't be that product anymore that you could buy because there'll be no support for even. So that'll be gone to the cloud. If you think about SharePoint, Exchange, most of those are dead now in respect to they've gone to the cloud. So if I do any work with clients, it's all based on on-premise stuff that they're actually doing, even from a development point of view. It's all client-side development. So from a logic point of view, one's going to be decorative, one's going to be imperative. Web jobs are, for all intents and purposes, dead, superseded by functions. There's just more advantages inside them. You can design them. I don't think there's anything that you can write besides file system that would be why you would not use functions inside the cloud. So web jobs, really, if you're going to go back to classic Azure, so before 2014, then there might be still a reason you might use a web job. I'd advise against it, though. So the only reason I'm bringing this up is really back to those hosting plans. So if you're looking at any of this stuff from a design point of view, consumption plans for our functions, we get 1 million free a month and we get 400,000 gigabytes per second. If we're looking at a premium plan, this will allow us to use VNet. So consumption models will not allow you to use a VNet. Okay, so one of the design issues there from a serverless kind of mechanism is you're going to have to premium if you want to run things from on-premise. So if I want to use stuff on-premise, like customer data, and I don't want that going to the cloud, I'm going to be paying for premium to do that. So they can integrate with either site-to-site or my express route. And then the other part to this is the app plan. So you're using this exactly the same as if you were writing this as a web application, which means you're paying a certain amount, estimated amount for that a month. The upside to the premium plan is VNet integration, but you also get up to an hour's running. So on a consumption model, the maximum you can run it is approximately 10 minutes. But it isn't 10 minutes. It's going to be a lot less than that. You'd probably run it for 5, so 600 seconds at most. Yeah. So again, going back to from a consumption model. But if you think about 600 seconds as processing time for a function, that's a long time in the cloud. It really is. And if you're writing things that take, run for 300 seconds even, that's an awful long time in processor time when 20 milliseconds is a time slice. Yeah, so you're running that for an awful long time. But the premium plan will run up between 30 minutes to infinite. So you can have that running all the time if you wanted it. But you're going to be paying more money. So you've got to see if that's worthwhile doing. The other upside to the functions, though, is they're scaled by Microsoft. So if you're using something like, as I'll show, something like API calls, or you're looking at some HTTP calls, and you've written Poly, or you've written some kind of resilient software inside there, when it checks and it's going to be resending this stuff, they will bring up new servers when it's seeing 429s. Okay, so if we run some software, so if I just fire some software, just want to fire something inside this. So I'm going to run some instances. So I'm going to run 1,000 instances. And I just want to look at this as we're running. So when we're running inside here, so if I look at live metrics, This should give us some live metrics where this is coming in. So this is running through, and at the moment, it's brought up 5 servers. So this is that application that's coming through where it's getting it from something being put into storage, and then it's running through this. You're seeing the request duration. So you're seeing some request durations in there, and these are the files being written to your storage. And one of the things inside here, this is running. So this is doing OCR commands, so this is doing OCR commands, and it's around 500 milliseconds. So this is just tracing. So this is doing an event grid, and this is processing that information, and there's new messages coming through. If we get a load of 429s, this is going to increase dramatically. So at the moment, at the bottom here, it's not using much processing power, and these are coming through, and there's no real dependency fails or other formats coming in here. If I change that, and one of the ways I can change that is at the moment, let's just change that back. At the moment, this is running on a pricing plan for the OCR. So inside here, this is running an OCR, and the server at the moment, it's got a pricing plan. The pricing tier inside here is S1, which means it processes 10 calls a second. If I make that to free and update that pricing tier, what we're going to find is this can do 20 calls a minute, and it's going to be throttled. So I'm going to see a big change. And when those processes, if they're still going through, and how quick that hits in. But we should start seeing dependencies when the actual message goes through. So it's either finished. Okay, so it's sent some more through. So this isn't going to cost, this is going to be free, but I'm only going to have these running. And when this comes through, what it'll do is run 20 for a minute. So as soon as it hits 20 that have been done for a minute, it's then going to throttle what it can do with the OCR. So this will get a load of messages coming through. And then when it actually gets it, I should start getting dependency failure. So it'll do 20 messages. And then you'll see the 20 messages, and then I should start getting, other problems inside here when it catches up, where I get dependency failure rate or things like that can't be called. Hey, this is clever. So it's done the 20 messages. This is so clean. It's really, I'd expect loads of failure rates in here. Yeah, so you can see the demos are going to go well. Jesus. So I'd expect to see a lot of red on the right-hand side. So it's saying it's throttling. So it's now throttling at 32. So this is actually waiting 32 seconds now. It's now done another 20 because it's another minute. But I would expect a load of failures. So obviously, I've done something stupid in there when I've written this. So I'd expect a load of call rate failures inside there rather than it's a bit too clean. I'd expect a lot of red in here. And when we got 429s, so when the processors were firing inside here and it was coming back with too many requests, I'd expect this to throttle this up to 10 or 12 servers. So obviously I've done something stupid in there. The throttling's working, but it's not much use when the actual cost isn't. Yeah, it's a chainsawing day or something, right? It was definitely, yeah, it's definitely done what I'd expect. So it's throttled it. I just would expect to see some more errors. So it's still throttling. I should get exceptions if this gets to 5 minutes kind of thing. So if it gets higher. But also if I'm getting something like a rush of information through, I should expect 429s inside there. So I'm surprised I'm not getting any kind of other errors in there. So I've obviously done something stupid in there. So this is still working. No, so this is actually doing more work now. So it's actually processing and I'm paying for this now and it's going to be coming down hopefully and doing this faster. But I'd expect to see those servers going up if I'm getting a load of requests coming through in here and it's not got enough servers to replace them, it would scale up. So normally inside here, he says, hosting from this environment will be responsibility of Microsoft. So on a consumption model, they scale automatically for you, but you're going to be paying for those new instances. On a premium plan, it's pre-warmed and you're going to pay for those services. So you've got that plan inside there. Yeah, this demo is going to be fun. From a development point of view, yeah, there's a multitude of different languages that you can do inside here. Most of this function app is going to be the hosting format, and then you're going to write functions inside there. So if I was writing something as a function inside my environment, and this is something like JavaScript, so this is a JavaScript function, I can have multiple functions inside here. I would advise you if you're using, your VS Code, you're going to write workspaces inside there if you want different versions of your functions inside there. So these are going to be predominantly JavaScript. If I look at the other side to this, got the same thing when you're looking at, say, something like functions inside C#. So you can write functions and they're going to be in C#. So again, we can write, process messages is going to be a function. So this is going to be a function where you could write this inside your environment. So this will be a function that you write inside Visual Studio. If you look at it, .NET. So we can write these in multiple languages. Yeah. And from a deployment point of view, you're just going to deploy these and publish them and deploy them to Azure in the state that you want to put them to. And depending on what you're writing, you'll see them inside your environment. So you'll see those under your functions. So you'll see those under consumption functions. And if you're doing the same thing in VS Code, you can deploy these to your environment. So these will be under version 4. So this has got 2 inside there. And the reason I look stupid is because I thought I had Azure already on here. So again, you can deploy to your functions. So you're going to be able to deploy your applications to those. So your functions you can deploy to your location. And they'll just come up with the functions that you're going to use to deploy. So both of those can be deployed from your environment. Anyone got questions on that stuff, or are you still awake? It's gone very quiet, so you're all dead. I'm going to fall over again. So from a function point of view, this will be serverless. And again, they can be quite useful functions, certainly in certain parts of most projects. And from a cost point of view, they can be very useful. Yeah, so you can run these, and key components in here, you can actually run these in multiple settings. So we can run them, and they're quite easy to run. They can be triggered, and they can be cost effective. Now, the other side to, what's going to make the cloud cheaper is stuff like storage. So inside here, if we're having a look at something like Azure, we have storage accounts which have a couple of things in there. Object storage, we can have file shares, we can have queues, and we can have tables. And these are built on their system. So file shares are just the same as what you're using inside Microsoft. So you've got mount, if you're looking at Linux, or you've got use inside Windows. Blobs are the interesting one. This is really going to be your object store. So you have page blobs if you're going to use VMs, read-write data sources. And we've got append blobs as well as block blobs. So sequential blobs are normally used for logging, and block blobs are really going to be your object store. We also have NoSQL tables, and we have what I consider a conveyor belt rather than a queue. So it's not really a queue. In these queues, you can actually take messages off the queue, make them invisible, make changes to them, and put them back on the queue. That is not a queue. Yeah, you can do that inside storage queues. So you can use these, but they're really backlogs, and they can decouple. NoSQL storage, though, if you can use this as a table, do you think this could be useful? Yeah? Why? Good saying, yeah. I use it a lot. It's practical, yeah. It's also cost effective, hopefully, isn't it? Yeah? That's it. Partition key, row key, and you're kind of covered, aren't you? Yeah? So again, it can be cost effective. And if you do, it does scale out about 20 instances per second, though. So that kind of, you might have hot paths and things like that when you're writing to it. So you might have to be careful there. But we can put the same data 15 times into the same table, kind of thing, if you want to. Yeah, so there's quite a lot of advantages for using it. And certainly from a cost perspective, it's very good. Yeah, 4.77 terabytes, you can have 200 of them per subscription. So you can scale out quite a lot with it. This is a kiss of death, and I try and stay away from it as much as possible. It's used from a lot of Windows administrators where they want to share stuff, and they have been using it for 20 years to put local file shares. And the downside to that is who's responsible for those file shares. And that's still the big problem, and all you're going to do is move that from on-premise into the cloud, and makes that even worse. Tables, I actually think they're quite useful from a cost perspective. So is there any downsides, do you think, to tables? What happens if you leave the company? Are there other people that know how to use tables? If you both left the company, kind of thing, would there be anyone? But that's the real problem. Well, from a development point of view, is you are normally the skill set goes if someone leaves. And that's why a lot of companies are scared to death if you write your own stuff, say, on tables. You know, they're a lot happier if you're paying a lot more money, but to write on a system that they can employ other people from. So all of your knowledge is one of the things that inside there with tables, you know, and queues are another thing that we could use inside there, but I think they're cheap and cheerful, but I don't class them as a real queue.
Question.
Go on.
So what makes tables so special from a knowledge perspective?
From a nothing, but remember I said I could get graduates. Most graduates will know how to do SQL.
Sure.
Yeah. So if I give them tables, how many of them you think will understand tables?
Okay, if you are used to stores like MongoDB? How different is
So document of Boson is slightly different to that as well. So you've still got to know how the tables work. Yeah. And when I'm employing somebody and we're at an interview and I say, do you know how tables work? And you go, no, but I could learn. What's the problem with that? Well, most employers are going to look at it, well, you don't do them now, so I don't want you. Yeah. If you come out as a graduate and say, you know how to do SQL, you can lie through your teeth. Yeah. Everybody knows SQL coming from as a graduate. How many people know how to deal with Redis? How many people know how to deal with Encache? You know, if we talk to those people coming out and I'm employing them, it's very hard to find. Yeah, and that's the problem. Not the fact that they can't do it and that you couldn't, after half a day, be quite proficient in the workings of that. I'm just saying, when you're employing people and you put on that advertisement, no Azure tables, one of the downsides is how you employ those people and how you've written the stuff. You know, there's a lot of stuff in there that's particular to how you write. You know, you're competent, you can write stuff quick, they can have things done in 2 hours. I employ someone new, it might take 4 days to get the same thing out. Yeah, just how it works. And you've got to live with that. So when I say, you know, the fact that they might not know tables isn't the fact that you can't do it. It's just the fact that when we ask for that at our interview, a lot of people are not going to be able to say, yes, I can do that. Or they're going to lie, say, yeah, of course I can do it. And there's not that much to it. I would agree with you. Yeah, but I'm just saying that's one of the problems. Same as Cosmos. You know, if I say to people, you know, have you written for a Cosmos survey? And they say yes. And I say, how does that actually work then? And how have you designed it? They go silent because they haven't done that. Yeah, it's a totally different design to EDMs. You know, we've actually got DBAs proper now again when they're writing for NoSQL databases because they need some knowledge on how that's being written and the best ways to do that. All right, certainly with Cosmos. So blob storage is actually quite cost effective. Yeah, it's one of the better things inside the cloud from all the cloud providers. It's how they're killing private clouds. So from a storage point of view, again, the main thing to remember here is this is normally public facing when you set this up. So if I use a storage account, and I'm going to go to my most hated video. So storage account. One of the things inside here, we have our containers. Oh my God. Maybe I don't. That's better. Data storage now. So I have containers. Why they didn't call these folders, I'll never know, because everything is now a container. But inside here, if I go to images, I've got my most hated video. So inside here, I can copy this and run this. And I don't find anything. And the reason for this is because we've got different settings for this environment. So this is set for private. We have blob and we have container. So we can have read only, well, we can have read access anonymously from both a container and from a blob. And at the moment, this has been set to private access. So there's no anonymous access. If I make it blob access, it's enough. So that's one that actually, you know, I can play. Yeah, it's a kiss of death though, so I try not, don't start. Yeah, so inside here, this we can use, but we can use object storage for unstructured data. So we've got videos, we've got music, we've got most types of data inside there. If I'm looking at tables, it's going to be more structured, normally rows and columns, so two-dimensional array formats inside there. So we've got lots of different ways we can store information. And the way this is actually being stored is under the storage name. So storad, whatever I've called it, blob.core.windows.net. And then whatever the containers are. And then in the end are MP4. If I am going to keep this as private, the other things we do have inside here are SAS keys. And this is where this could go really well because of timing. So inside here, if I want to create my environment in here, I'm going to create a SAS key for this setting. So this should say can't find it. And I'm just going to put a SAS key on the end here. So hopefully in here I can create shared access signature. This is going to be for a blob. I'm going to use on the container and the service so I don't look too stupid, but get rid of everything else. If you are going to take the exam, make sure you look at SAS keys and just know what the variables are for. It's saying in here that is, okay, so this is saying your time. We'll see what mine actually does in a second. So in here, I'm just going to give it 3 minutes. And inside here, HTTPS only, I'm going to use it to a key, and I just want to use the SAS token. So I'm just going to put this SAS token to the end and add that to whatever's at the end here. And at the beginning of that, I just want to see if there's a question mark before it puts the V. Okay. Hey, that was bad. Actually played. So I can use private, give you a SAS key for a certain period of time. The downside to SAS keys is really they're open for everybody. I can't stop them in respect to if somebody has them and we've got them for a certain period of time. If I say, you know, you can download some content, I'm going to give you a SAS key, you pass that to all your friends, they can also read that information. So I can't actually turn that off as I can do with, say, certificates. So inside Azure, we normally would use policies, and you can use a policy to stop that. Yeah, go on.
So it's not an access token.
So no, you can't revoke it. Yeah, well, that's one of the, I mean, we used to use ACS, and over a weekend, Microsoft changed that and put it to this and killed everything that I did. Because we used to use Azure Container Services, and that was a different mechanism. It was a token-based system. This is where you're using a valeting system. So if I have a shop, I give you, sir, I use this for credit cards, things like that. I don't want you to be able to get in there, but I want you to give you some download location. I give you that token that's added to your HTML in that token. It's a valeting system. But you could give that to everybody else, and they could then get into that for that period of time. Yeah, and inside it actually tells you what the time is. So if you're looking at it, you can see that as well. So if you've got storage public facing, this is one of the things you could do, or you could write something else in there from a subscription point of view. The other thing we've got with, say, storage, though, besides, say, static websites, is also stuff like replication, so zone replication. So when I create storage accounts, but you can't wait for those donuts. So inside here, we've got locally redundant, we've got zone redundant, locally redundant. So we get 3 instances on the same data center. So they'll write them in different locations. If you're getting rack failures or you're getting network failures, they'll be in 3 different locations. If you look at geo-redundant, you get the same functionality, but over 300 miles away, it will asynchronously write that to a second location. If we're writing this under SDKs, we can get to the second location if we make this read access and use that as a location we can read from. So why could that be useful? If I'm using storage, I'm going to write it in one location, but I'm going to write it to another location, but it's read only. Why could that be useful to us? Say you're writing reports. Do I want to look at the read-write place when I'm writing reports? I want you to read from somewhere where it's already there. You know, anyone that says they need real-time cursors is normally lying to me. You know, if you ask them what they actually need, you know, an hour is good enough in most instances I've come across. If someone says they need real-time cursors and we need to know exactly what's happening all of the time, and you actually ask them if that's what they need, you'll end up it isn't. You know, they just want some information up as quick as possible. So geo-redundancy, if you're looking at big data or report writing or things like that, your secondary location can be really useful, and it can be cost-effective. Zone redundancy is going to be available in some regions. So this will give you 3 data centers. So if you're looking at most of the big primary areas, you're going to have 3 data centers, and they will be written to that in your zone redundancy. And geo zone redundancy is going to give you that right in a secondary location. As it says underneath this, you also get a tick box to say whether or not it's read-write. Yeah, so if I have this read-write in the secondary location, I can use that. There are some other things inside here where using secure, anonymous access, so by default now that's off, so it's private. If you're now enabling this with a key access, if you're using Enter ID, so they're inside your organization, if we want to use our other settings in here, I can create a data lake by ticking that box. So a data lake now is created in here as enabling hierarchical namespace. I can have secure FTP. So I can use this storage as a black hole. So we can put petabytes of data inside here, and we can use that as our storage mechanism. We've also got other settings inside here, stuff like data protection. So some of the things inside here, you've got purge protection, but you've also got stuff like version immutability. So in other words, you can use this for case, and you've also got change feeds as well, so you can do tracking on some of this stuff. So storage can be quite useful in a lot of areas and fairly cost effective because of that. Okay, as well as encryption. So storage is fairly useful in most cloud providers, as well as Azure. And the other one, as I say, is static websites. So, and the other thing it's got is lifecycle management. So you can actually write rules to move stuff between hot, cool, to cold, to archive. Cold and archive can only be done per object. So you would have to actually do them per object or change them by object. So hot and cool are the only things you can do on the actual storage account. Okay. Anyone got any questions on this? Anyone's still awake?
How
What?
do the blob storage in Microsoft differ from the S3 of
Very little. The same idea. Yeah. I don't think there's really any differences inside there. I can't think of any off the top of my head. You've got encryption the same way. They're public facing by default. They are really an endpoint that you want to write stuff to. So they're almost exactly the same. Don't forget everything that came in Azure, near enough, they looked at AWS and said, yeah, and even if today, every one of them looks at each other and says, if you're doing this, we're going to do our other implementation of that. So they're all doing the same thing. Yeah, so they're very samey. It's an endpoint where you can write something to. Yeah, so there's very little difference. Yeah, that I've seen. The big difference I've seen between, say, something like AWS and Azure is API gateway. One will cost me 20 pence and the other will cost me $2,000. Yeah, no, API gateway is very cost effective inside AWS. If I look at the premium version in Azure for API management, it's ridiculously expensive. They do a lot of integration, it's a gateway, but it's expensive for API kind of format, especially if you're just using Swagger and you've got 200 instances kind of thing. It's very expensive. But most of the other stuff is very like, and they look at each other to do that. All right. So before your pastries, so one of the things inside Azure they've got is Cosmos. So this is a NoSQL database. There is quite a lot of design you've got to think about with Cosmos if you're going to use it as a NoSQL database. Predominantly your physical kind of partitions you've got to think about around the 20 gig mark. So you've got a lot of design there to think about. The costings of this are better than, say, SQL from a licensing point of view because you don't pay per license. So if you are looking at something like Cosmos, there's a number of things inside here that are going to be an advantage. The fact it's a multi-master write is one of them, but the other thing is the fact that you will have different types of data source that you can write in there. So, and this hopefully is the last thing I'm going to waffle about before you get your pastries. So inside here, if you look at Cosmos. So in Cosmos, we've got a namespace, which is really what your database is. Okay, the reason I was a bit slow there is I expected to see this. So this is our namespace, so this is our database. These are our containers. So inside here, if I put some data inside here, this is going to be in this case, a JSON format. We've got different types of container we can put in here. So we can put Mongo, we can put Cassandra, we can put SQL-like syntax. So we've got different types of API in here, Gremlin. We've got other features inside here. So you've got stuff like data replication, default consistencies. So if you're looking at, say, something like strong consistency, this is very like transactions, where this is going to have in order. And before it moves away, everyone has to agree that this information is going to get written. So if you're putting these in multiple locations, this would be one of the things it reads. So if I use this and replicate this data, so if I put this in East US, I put it in Poland, and then I put the default consistency inside here. I don't want to pay for that actually. But the first four, so the first four are going to be in order. So consistent, prefix, session, stateless, or I should say bounded, staleness, and strong are all going to be in order. So this will be limited to a bit of time. So some of these things that have a maximum time limit, in this case, a delay of 5 seconds, but they're all going to be the same color as the starting point. So this will be staleness. Sessions are going to guarantee you read and write sessions, but again, they're going to be in order. So these will be guaranteed in order. Consistent prefix, at some point in time, they're all going to be the same. So there will be other latencies, but you're not going to make Microsoft keep to those latencies, so they're going to charge you less. And the last one is not going to be in order, and it's going to be eventual. And this will be not in order. It'll be up to you as a developer to deal with how that data is actually going to be run. So this is going to be the fastest mechanism, but you've got to do some of the logic that's going to work around that. This database can also replicate data globally. It can also do multi-master writes. So you can actually set this up to have multi-master writes in the 40 locations where I'm actually doing this. So the upside to this is we can actually have multi-master writes globally. If I look at this disable, this will be very much the same as SQL. So I can have a primary and I can have a secondary location. And depending on what consistency level I write, depends how that's going to be actually dealt with. So at some point in time, if I make this the slowest, almost transaction-like, then both of these will have to agree before anything's written and we can move on. So it's going to be the slowest format. So Cosmos has global replication, different consistency levels, low latency based around the SLA, and we do have elastic throughput. So if you're looking at, say, tables that run out about 20K at, say, something like storage, you could put that into Cosmos and have hundreds of millions of requests a second. So you can do that. This is a NoSQL database with multiple different APIs, but predominantly everything is around the container. So when you do create things inside Cosmos, and I create something on a container, the throughput is how we're going to pay for this. So if I add a new container, one of the things I can do inside here when I'm looking at the costing of this, so when I'm doing provisioning, I can use auto scale. And what this will do, if I set this up, 1 RU is 1K per second read-write. So if I'm setting this up to 1,000, it's a meg read-write per second, but it will start off at 10% of that. So 10% of the max RUs is going to be used at the start. So if we auto-scale this and we get away with just using 10%, then it will do that. If it needs to scale more, it'll go up to a maximum of that throughput. And that's where your costs are going to come in here. The minimum you can have it at is 400 RUs per second. But this is where you're going to be paying this for throughput. So how could we make Cosmos cheaper?
Use Postgres.
Okay, comedy isn't dead. Yeah. So,
Scaling, no?
sorry.
Question about that scaling.
Okay.
Have they started scaling down automatically, or is it?
They have and haven't. Yes, they say they have, but I haven't seen they have.
Okay.
So
last time I looked at it, it was not possible to scale down again ever.
well, no, it will. If you scale up, the idea behind this is it is going to. It is supposed to auto scale and move down with those scaling formats. So do some tests again, but from what I've seen, they have started doing that with auto scale. But this is fairly new anyway. So the auto scaling is fairly new. It's only in the last, I'd say, couple of months. All right. So inside here, though, if I have a queue, could I pass stuff slower to this environment and pay less? I can buffer it. I could pay less just by buffering this stuff. You know, if throughput's the format you need in here, and I don't care that this takes 2 hours to actually have its values, I can pay a lot less than I can pay with SQL, where I'm paying quite a lot of other costs inside here as well. So you can determine how much cost is going to be done inside there. So checking inside it, I will check if you scale down as well, because I thought they did, so I'll have a look. So inside here, that's how you're paying with throughput. So a lot of the things inside the cloud are going to be done on throughput. And containers probably the most important thing to design. So this is where your provisioning is actually be done on your container. It's also where your APIs are. So you've got different formats inside here that you can use. Your database, for all intents and purposes, is a namespace. If you're looking at a SQL format, then this is going to be around JavaScript to write stored procedures and triggers and user-defined functions is all JavaScript, which I didn't think was the best format, but if everything is JSON, makes sense. So Cosmos has a look at different formats from your consistency level. Strong consistency is very like transaction-based systems, right through to very weak consistency, which is going to be the most performant. So depending on how you're using that, eventually this will be the same state. There are different APIs. So you do have NoSQL and DB for tables. You've got other settings inside here if you're looking at Cassandra, Mongo, or Gremlin. And there are others as well, ETC and those kind of things in there as well. But consistency guarantees something that you've got to look and tie to your update. So something worth looking at from a cost perspective. So you do have different types of APIs. They're at the wire protocol format. So some of these are being used in different formats. And the reason is underneath the covers, this is using ARS, atomicity, structures, and resources is the term they used when they developed it in 2010. But the format inside here is predominantly provisioned throughput, serverless, or auto-scaling, okay? So again, you could have this as serverless. So you can have your function-based systems passing stuff to Cosmos. The other thing with Cosmos you've got is you've got your change feeds. Yeah, which isn't that one. Can you make this any bigger? No. So the other thing you've got inside here, you can use Cosmos as your change feed. So this will have events that could be pushed to functions. It could be pushed to your middleware or your big data kind of format, data science formats, or move to your data lake or other systems that are going to be ingesting this. And you can do it the other way around. So your functions can push all this into Cosmos. So depending on how you set these up, you might also do conflict management with that and some other things in there as well. So change feed can be quite useful for, say, conflict management. Yeah, because the normal way that works is last one in wins or first one in wins, depends how they've set it up. But you can use conflict resolution, where you can actually set up how this is going to do and what resolution you want to do inside it. So you can write some rules that are going to do that for you inside something like Cosmos. Anyone got any questions on that? Because I've bored you to death. And hopefully you've got some coffee and some glass of got.
Yeah, it's more kind of a general question.
Yeah.
For the moment in Norway, among the customers, Azure is quite sought after, like knowledge of Azure.
Right.
From architectural and developer and also a cost point of view, what is the sort of killer feature of Azure, or why would you choose Azure?
So a lot of the reasons for Azure are normally hybrid. Yeah, hybrid compared to the others, hybrid. So if I'm a Microsoft house, a lot of the work I do is then moving them from areas where they've already got this on premise, and how do they move to the cloud? And lift and shift is a really bad idea. So how do we re-architect it so they're using most of their systems in the cloud competently at a good cost performance kind of ratio? Yeah. So unlike, say, something like AWS, if I worked for a supermarket, AWS would be the first thing we'd go to because they offer me a service. You know, that's what I get from them. You know, this is the EPOS system. That's how it's going to work. All that can be tied together quite well. If I look for something like an enterprise system, doesn't work the same way for them, especially if they're not on an open source kind of mechanism. You know, so a lot of the things they're going to move from, honestly, is 365. So a lot of them start using 365. They put a lot of the things, they get rid of their Exchange people, get rid of the SharePoint people. They're putting all that stuff on in the cloud. And then they're saying, how do we extend that kind of stuff? And that's where Azure comes in. So that's normally the progression they go through. You know, and Microsoft say, we'll give you all this stuff. And this is what you can do. You're paying us an enterprise agreement anyway. So that's where you can move to. You know, so that's a lot of the format you're using in there. Yeah.
If you sort of would design a completely new app and you don't have any legacy on-prem systems, then
Yep.
you sort of...
So from that point of view, you're still going back to what is their primary development tool. I mean, if you're a Java Unix house, then you've got a wide variety of things to choose from. You know, and again, you might find that Google work out to be better than AWS or Azure, you know, because they're giving away a lot of stuff at the moment because everyone's stepping away from Google, you know, because they look at all your details, you know, depending on what their licensing agreement is, means they can look at a lot of content. So certainly in the UK, there's a lot of companies that are saying we're staying away from Google because of that issue, you know. AWS, we've got supermarkets moving away from AWS because of fresh foods. So historically, they bought fresh foods. Well, they're in a competitor for a lot of the supermarkets. They're not going to host their stuff on a competitive environment. We won't look at your details. Well, you might. You know, that's the way they're looking at it. So Microsoft got a lot of their actual work from, say, big supermarkets. And they were not the same way as you'd get something from AWS. Yeah. But if you're integrating your systems to back-end services that you've had legacy-wise, Azure makes a lot of sense for them, but if you just move it from on-premise to the cloud, it's a really, really bad idea. As companies are finding, if you lift and shift something, it couldn't be worse because you've gone from a capacity model where you did projects based on getting some money for projects, paying for those, and then getting them free once you've written the stuff off. That's not true in the cloud for any of the providers. It's a rental model forever. You're always paying. Yeah. That's why you've got to think cost performance because you're always paying. So how do I pay less? Yeah. And we can pay less, but you're going to have to do. Has anyone come across, have I been pawned? HIBP. You know, Troy did a lot of this in 2018, where he broke down a lot of the costs. So he moved into the cloud. So he did a lot on serverless, and he's done quite a few. This was about 2018, I think. Yeah, 2018. So he did a lot of work with going down between SQL tables, Blob Storage, Cloudflare, writing a lot of other stuff, going functionless or using functions. And he goes through all of this. And one of the things he found, what the costs were for him, was it was costing him 80 cents a month. You know, so he designed this. His biggest problem was getting 500 million records up into the cloud, and he was having to write that in the first place. So this is with Cloudflare. If he takes off Cloudflare with the way they actually worked, it cost him about 280 a month. Yeah, so he was looking at, you know, 280. Well, if you think his costs he was getting for this advert would have offset that in the first advert kind of thing, it was costing him nothing inside there because of what he was getting off there. And Firefox uses this all the time, you know, so you can check if your password's been pawned or whatever else formats are in there. So he did a breakdown on where those costs actually come in for him. And this is what he actually came out. He had a lot of help with Microsoft. And as I said, Cloudflare did a lot with them as well to get the other costs in there. But that's what he actually looked at from a serverless kind of mechanism for him. because all he had really was a load of data that you could just manipulate. So depending on what your applications are, depends how that's going to work. But he did a fairly good breakdown, and he did some updates to that. So he did some cloud cost updates where he went through some other costs, did a load of analysis, and showed what he actually got the best out of that and where this was costing him money and what other formats he had to do. So he actually did quite a good breakdown. So Troy did quite a good breakdown on this information. So why you would use Azure over other things, though, is predominantly coming back to what is your systems that you're currently working with. You know, if you use Java and Linux, then you're probably more AWS inclined anyway. If you're using a lot of legacy Windows apps, you might use the cloud. So it depends what you've got in Norway around that kind of format. Okay.
One of the main historical reason is that lots of companies are using were using Active Directory.
Yeah.
And they kind of stuck in there. And then it's Azure. You just don't have a choice with that.
Yeah. Well, you could, because you can get rid of Active Directory altogether, but if they're using legacy apps, yeah.
You know, some companies are like all access in 6,000
God, yeah.
employees.
Yeah.
They don't
That's a good point, yeah. Also, you've got knowledge there on how that works. Even though if you use something like Azure Active Directory or now Enter ID, it's flat. There's no X500, it's not LDAP. It's completely different.
But I think it's the only system you can import from Active Directory to the ADFS. Or
yeah. Yeah, you can use others. I mean, they've got, what's the other one that starts with O? They've got Shibboleth, but they've got some others.
I think if you have an Active Directory historically in-house, you can
use the cloud. So if you've got Active Directory, you can actually use it directly inside here. So if you go to your Active Directory, and they actually did limit it. That's a good point, sorry. Yeah, they limited it, didn't they? They used to allow you to use third parties, and they got rid of that. So yeah, Enter ID, when they changed the name in here, if you look at the cloud synchronization kind of format, they did make it so that everything was from their Connect format. So I used to have work with, say, IBM Portal and that kind of stuff. So you had different LDAP kind of formats. There was also, just trying to think what the other one is. There's Shibboleth, but there was other settings inside there as well that you could connect to. And they used to allow those. But as you say, they've stopped this now. So everything with Cloud Sync is really if you've got Active Directory on premise. So they did change this. Good point. Yeah, so Cloud Sync has been done through that. So you've got federated, you've got pass-through, you've got your seamless formats. But yeah, everything is integrated with that. So that's a good point. That's another reason. Yeah, good point. So if you use an Active Directory, you are locked in. Yeah, which is how Microsoft works, how Apple works, how Google works, how all of them work in a lot of respects. All right. Everyone all right, take a break there? Okay, so if we're looking at Azure for containerized solutions, most of the actual work in here now is pushed to more Azure container instances, which are fairly useless. Certainly if you're going to take in the exam, so that's where this is pushed to. So it's using Docker. As I say, the most interesting parts to this are not container instances. Most interesting parts of this are looking at container apps. Okay, so container apps are probably the most interesting side to implementing stuff in Azure where you're paying for as you consume. The other thing they've got inside here is container registries. So, all right, maybe not. So container registry. So we're putting content inside here under repositories. You know, we can deploy stuff. So we can actually use our images and push them to container instances or deploy them to web apps. So container registries can be quite useful. You can do tasks inside here as well. So we can use this for our private container registry, and we can push these to, as I say, container apps. Do we think container apps are a good way to deploy stuff in the cloud? Be it on any cloud provider, not just Azure. Is it any good for any of those environments? Do we think container is a good idea?
Yeah.
Are there any downsides, or is it all good? So you say yes, so what's the upside? What do we think the upside to containers are? Do we get higher density? Can we have higher density applications on the same hardware as compared to, say, virtual machines?
Yes.
Yep, so higher density is one of the upsides to it. Any others? Can we?
Agnostic?
So what's agnostic?
Really matter what cloud provider you run it on.
So the images are portable, yeah? So, and you decide on the operating system. And predominantly, hopefully, it's going to be Linux, yeah? Because no one puts anything on Windows. So hopefully it's Linux, yeah? And I would agree, they're portable. So the upside to that is we can do this on a laptop, we can do this on premise, we can push this to the cloud. Yeah, so it's agnostic in those areas. Anyone playing around with WASM? With Docker? Anyone looked at WebAssembly? Yeah. What's the upside going to be with WebAssembly, do you think?
Hopefully smaller runtimes.
Okay, so faster runtime, smaller runtime, binary stack image. Yeah, the fact that we can host that and Docker are doing work inside there. So we've got operating systems that are going to be based on that. So if we're writing stuff on it, you can, certainly in the cloud, you'll be able to host this on almost all hardware because you're just going to create it into a WASM standard. Yeah, so that's the true idea in the end. I don't think we're there yet, but WASI and WASM are making big impact on some of those areas. Yeah, so hopefully we won't have to just rely on certain operating systems like Linux to make everything work. But they are portable, so they're agnostic across those. Any other upsides? Would you design all of your systems really around container-based formats? Which a lot of companies have done, by the way. Yeah, what's the upside and the downside to that? Well, as you've said, they're binary, well, I should say they're portable formats on their image. So if you're doing your development, hopefully you can deploy that to almost all platforms, be it any cloud. It doesn't have to be Azure, it can be any of the clouds. You can run these on top of orchestrators. So again, from a point of containers is how do we administrate them? And that's where Kubernetes or Swarm or Wrangler or whatever you're using in here hopefully can make that viable. So we've got a way to actually run that. So what's the downside? Why doesn't everyone just use containers? Is there any kind of learning when you're looking at containers? Do you think Kubernetes is easy to understand? Is there any learning curve on that? Or is it?
It's really complicated.
So from a deployment point of view and a runtime environment, it can be quite complicated how we do that. And side effects, go on, sorry.
To be honest, I would not be able to install Kubernetes at the client myself.
You would.
Well, I have never done it, but I can do
A
it.
couple of clicks. It's not hard to install. I think deploying containers on it and making them run well would be one of the arguments. I think anyone can install, I think, the nodes. Yeah, and you could do that across zones and you could do that really well. But when you come to actually running those containers, I think that would be an issue.
Yeah, but that I can do.
See, that's the issue, I think. Yeah, your YAML design, how many replicants you have, how you're going to set that, what your fallback is, what your deployment mechanism, how does it fall over, what does it roll over, what run once formats do you do? All those, I think, can be quite complex. Yeah, so that's the real kind of issue, sorry.
Yeah, monitoring is more complex.
Monitoring's going to be a lot more complex if you're not just going to use local logging or other formats, so your Prometheus and other things to pick that up from, hopefully. Yeah, another point you were going to make, sorry. Yours is the same point.
Just saying, that's why we have a platform team to.
Yeah, I like that. Yeah.
Not our problem.
Yeah, not our problem. But the problem from, say, a developer point of view, if you were going to be doing this on your laptop, and you can run Kubernetes on a laptop, those kind of things, or you're running it in your MSDN subscription, you could test all this stuff, see how it performs. Communication between anyone using Dapper? Anyone looked at Dapper? Yeah, so if you're writing microservices, yeah, one of the things in now is how do we write? Can anyone remember actors and all the other things that we had about 10 years ago for writing microservices? How well that went? These are supposed to be the standards. So they did a lot of different formats inside here where we have different type. All right, maybe we don't. Or it'll just catch up. So we have different types of configuration and format. So server-to-service invocations, actors, so message-driven, symbol-threaded. These kind of things were big 10 years ago, where these were set up and you had single formats, observability. So when you're tracing those kind of things, pub sub, how you're going to create those, state management, your CRUD options. So these are all really the standards that we're using as a format to communicate between those microservices. And in this case, microservices are running in these containers. So this is how they were actually being standardized. So Dapper is one of the things they actually did set this up for, so you could have a standard way of communicating between those. And again, that's what's got inside their communication formats in, say, something like container apps. So how you create long-running, stateless and stateful services, was some of the problems we had when we're looking at microservices. What your event sourcing is, what the truth is, these get fairly complex. So some of the areas inside there in the learning curve could be quite high. So if you're just using sidecar and an application, that's great. But if you're into more depth and you've got thousands of these containers running, how you actually look after those. So from a point of using these, one of the things that Microsoft, as I say, now does is looking at more container apps. And I do like the idea of container apps because you do pay for what you consume. So like all things, if we run this with logic and we're going to run tasks, then this might be great. If we're going to host stuff, it might not be. But it does have scaling in there. It does act as a secure boundary inside here, so it does a lot of the pod work for us. We can independently set up how that functionality is going to work inside your container app. And if you are looking at Dapper, you do have distributed application runtimes kind of things inside there. So you can actually set those up and use them as services inside that container app format. So you can deploy these. They're fairly easy to deploy. As I say, communication between these could be a bit more involved. But they are actually quite quick to deploy. The other thing they do, though, is create you a secure environment. So if I set up a container app, so this is going to create me an app environment. The container I'm just going to get from my container registry. It's got a list. Mine will be a white cat, a snowstorm, so there's not much in these. Development stack generic. I'm going to use 1/4 of a CPU, 1/2 gig of memory. Bindings in here I'm not bothered about. Ingress is going to be unsecured. If I was doing it secured, so this is going to have traffic from here. I'm allowing insecure environments. You wouldn't. You would set this up if you're going to use gRPC or other formats. You're not going to allow 80. And I'm going to delete this in a second. But if I'm using others, they'd just be from an IP address that I'm actually using. So certainly from a development point of view. This shouldn't take that long to actually create. So this is creating this, putting it on top of your Kubernetes environment. I'm running this as a container. And it's definitely slow. So inside here, it should give me a secure environment. But this is my app URL, so it's running on top of my container app environment that's been put on top of my environment. So there's nothing in here, it's a white cat and a snowstorm. But the fact we can set that up fairly quickly, and this is a container app that's got a lot of functionality in there. So we can set up multiple containers running inside here. You would set up what the environment variables are, health probes, other settings, scale up. You can use your volumes, where you're going to write to if you're going to do so. You've got authentication settings where you're going to set your secrets, so you do have this local. We can set up ingress so it's a lot more secure, so it's coming from certain IP addresses, and we can deny other formats. When we do deployment, we can say how this is going to be deployed, where it's going to come from, other settings. They're doing service containers, so you can connect this to other services now as well. But one of the most interesting things is the fact that it's quick to die. So we can clean these up fairly quickly. If I am using container apps, again, there's going to be a lot more security in there. And you do have managed identity and things like that in there. So, oh yeah, okay, because it's no longer there. So we do have those kind of settings in there. So quicker to set up than say Azure Container Instance, which seems to take an hour. So inside here, we can set up our containers. You can set these up communication between your containers inside your pod and other settings that they're going to host inside there. We've got our isolation based on that kind of format. If we are using something like Dapper integration, we do have different ways where we can actually use these from an application point of view. So if you were looking at state management and you want transactions and CRUD operations, you can set this up to use those kind of formats. Okay. So container formats are going to be the same in most cloud providers. So in a lot of formats in there, the only upside, I think, as I say, with container apps, is really this is running on top of Kubernetes for us, and we're only paying for what we consume. So when you are looking at, costs for a lot of these kind of container apps, one of the nice things is if I'm not doing anything with it, so in my case, if I'm not doing anything with it, what are my costs going to be? Well, if I have Kubernetes up, I'm going to be paying all the time for those nodes I've created. And I'm normally going to create at least 3 nodes because I want them across a zone. So underneath the covers here, the orchestrator is going to cost me a bit of money.
Question.
Go on.
Can I expect that Dapper is supported on any other cloud providers, or is it Azure?
So Dapper is an open standard. This is one of the things they tried to get because 10 years ago, everyone wrote their own and had loads of other problems. So Dapper now is supposed to be a standard between microservices when you communication. So yes, you should have them on all other providers as well. Yeah, and it should come under that standard as well. I don't know whether AWS and Google have that, but I'd expect them to. I haven't tested it, to be fair. But I can't see a reason they wouldn't be in there, and you can communicate to those containers as well.
Sure, but if you write an application towards Dapper, it's a Dapper application. It expects that API, right?
It expects it to be that format, yeah. But you had that, remember, you had that problem before. If I wrote an actor and I want single-threaded, and I want that actual actor to be able to communicate with state, I had to think about that from a standard way of doing that. And most of those were third-party. So I couldn't do that with anything else but those third-party tools that they created. So at least Dapper should be an open standard. I don't know if it's available all cloud providers, but it should be an open standard. I've never looked, to be fair. It's using Keda, so I'd expect it to use. It's under the Dapper docs. Yeah, building blocks. Yeah, they're going to have the same things inside AWS as you'd expect. So they've got the same kind of thing into Google, I'd expect as well. So all the cloud providers should give us a standard for Dapper. Okay, if we're looking at the data plane, we spoke about this earlier with, say, Microsoft. So Microsoft's authentication mechanism now, MSAL, really, we don't do a lot of work anymore. Go on, sorry.
A bit back, you say it's on-demand container apps. So they go down to 0.
So I don't pay for them if I'm not consuming.
Yeah, but it's basically by default they configure to go down to 0 scaling.
Yes, they won't use any kind of resources.
Would it be is it a problem? Is it cold start?
I was going to say, you'd have to test that, but I haven't found that cold start's that much of an issue inside running those. If you think about running Kubernetes, though, they're actually fairly quick when you're normally bringing up pods or bringing new instances up with those pods.
I guess you're not writing Java.
Sorry?
I guess you're not writing in Java then.
I write in C#. Yeah, so most of the stuff I do. But even so, Java, it's not that slow. I mean, NetBeans was the thing I hated, but the rest of the stuff with Java I thought was quite quick.
Yeah, usually a container takes seconds to start at least. We don't work.
Yeah. Does Kubernetes care if you write in Java, really?
No, not in itself.
Right.
But if it's a cold start for those containers, it would take time for most of us writing Java applications.
Yeah.
This is Spring Boot at least.
Yeah.
Yeah, but that's the framework.
Yeah, I know.
Starting
That's my point.
Is it like a stored procedure in the first place? First one's expensive and the rest come up quicker?
No, it's basically the startup. It takes time. You know, Java.
What you saw there when I put it up, when I've deployed it, it's going to take time when that starts up. Yeah, but...
That's a bit of my question.
Right.
When it's deployed, is it a cold start or is it a warm start?
So it will be a cold start on the container format. Yeah, so it would be a cold start. So you'd have to look at that to see how bad of an impact that was, yeah. And the other thing with that, I suppose, the same as our application, you could do initialization. So you're going to start that up before you start doing anything with it. But again, it's that first call. Yeah, that's what you'd have to test.
And the function can run containers as well, right?
So the functions can run...
Containers.
How do you mean when you say run? The functions can run containers, pass information to containers or call containers?
Start from a container instead of some JavaScript, or basically the functions. I don't know in Azure.
No, so in this case, you're writing functions. They're going to be either consumption, premium, or whatever, but you're writing your functions. So you're not going to normally put them into a Docker environment. You're just putting them straight into a function inside Azure.
Yeah, okay.
All right.
Let me rephrase. In AWS Lambdas, it's actually containers running.
Right, I get it. Yeah, sorry. Yeah, but they did that to speed up the cold starts, didn't they? Isn't that one of the things they did in Lambda? No, I think that was why they did it. That was one of their big issues. You know, the other thing that AWS said is they don't want you running so many containers with little bits of code in it because the overhead is killing them. They're going to create, what was it, smaller VMs that start up that you can run all that stuff inside a VM.
Yeah.
So they're trying to design smaller VMs to start up quicker than running them in function, serverless.
So what would be the difference of writing container apps that would go down when it's not in use and a function?
So very little. They're still going to have cold startups unless you're going to warm them first. So depending on that, you'd have to do the testing, see which one came up quicker. Yeah. And I haven't done a check on that to see if that comes up quick enough.
No, but kind of, I would guess that the container apps would wait a little bit of time before going down.
There's going to have to be some kind of provisioning. So yes, that's going to take a little bit more time.
I think to turn down.
To die off. Yeah, so to stay up for a bit longer. A couple of minutes, maybe 3 minutes, and wait for someone else to come in. Yeah. But a function, you can normally start up in about half a second. You know, as I say, if you're pinging them, they normally come up with about half a second. So you're looking at half a second normally to kick a function off, you know, and that could be any kind of function.
I was just thinking use case one against the other, right?
Yeah, I mean, I do think your functions are going to be cheaper if it's not as complex because you're getting 1 million free a month.
Yeah, and containers you pay from the first.
You're going to be paying as you use resources. Yeah.
There's no free tier.
And there's going to be a provisioning fee and use inside that as well. So when I put up there and it said a penny, that's because I'm not using them. Yeah, so if I'm using Redis a lot, then I'm going to have more costs inside there. Yeah, and I will do it. I'm going to do a test to see how long it takes up because you've said, you know, how long is that going to be? So I'll do some tests to see myself how long that takes to come up.
Yeah, just a quick
Go on.
question regarding Dapper. Could you run Redis in Dapper as a container app?
So Dapper is a communication kind of format, yeah?
Just to understand what is your delivery to the Dapper when you want to write a Dapper app, what?
So the point being of Dapper is we're going to use microservices, but you want to write CRUD services. Yeah. So how do we write CRUD services when we've got stateless microservices or things like that? That's where Dapper is the standards that you would look at. Now, we used to look at third parties for doing that and build around their framework. Yeah. And microservices and nanoservices are a pain to design because you've got to spend a lot of time at the start. Yeah. So a lot of companies aren't doing them. But the idea behind these were if you wanted something like actors, which used to be the big thing when we're writing stuff where I can only make a change to a location. I want a single thread to make a change. And we were getting race conditions or other things. We went to different systems to be able to make that change. And that was a third-party tool where they wrote a lot of logic for you. So inside the framework, you could write those systems. Yeah, and that's what they did. Now, we've got a lot of frameworks that do that. We've also got a lot of Dapper and open standards that meet those criteria. But if you're looking at Redis, say, that's an endpoint that you're going to store data in and keep it as a data source or an in-memory representation of that data source. So it's an endpoint I want to write to. Yeah, I'm checking if things exist. I want to get data out. I'm generating stuff. Whereas Dapper is really the standard that's going to say whether or not I can talk to it without getting a race condition or affected by someone else doing that. All right, so these are standards. So the API really writes some logic for you so you can write the way you want to do it. Okay, but you still have to use their standards. So they'll have written some. So say in .NET, we have a lot of things that do parallel. And when you do parallel, a lot of the problems were how do we make sure only one thing is changing that at a time? Well, they've done a lot of work in Missile and things like that to make that easier for us from 8 and above. So I can write tasks now, and the first task that finishes comes back to me. Believe it or not, that was a real pain before 8. Or 9, I should say. So when we were doing tasks, we had to do a fetch list and say which one had finished and then grab that and do all that kind of work. Well, that's really what this is trying to change, how we process that work. So that's all Dapper is a standard. So there's a standard globally now that says instead of using these third parties, just write things to this standard and you should be able to call any others as well. All right, so that's the idea behind it. Yeah, so this is more about the fact that distributed applications have different standards to most other formats. You know, source of truth and things like that. Go on.
Is this Dapper the same as the thing described on the Dapper IO page?
Yeah, the same thing. Yeah, Dapper IO and this are the same thing. Yeah. So the idea behind this was there's some standards. Yeah. If we're looking at identities, the whole point of this now really is MSAL. So they've made it much easier. I should say most of these have made it much easier for us to write stuff to our environment. So if I, start writing Blazor, most of the work now is done for me. I change 2 things in a JSON file and my security works, okay? I put the tenancy in there and I put a client ID or application ID. I put a client secret in there and I can now use my application, it authenticates. I've done very little work now. If you go back to 2 years, we did loads of work setting this kind of stuff up. So they've gradually made this simpler and simpler to actually use. And we worry about really our token ID and our actual token that we're going to be using with this. So, you know, if you're looking at different mechanisms to talk to this, most of this is going to be about your token that you're going to get to actually use it. The only thing MSAL did was really add your social and local kind of accounts and made it simpler. So this, you can still look at your different ways of talking to this, but essentially, you know, you've got some kind of token or the system in here, so you've got some kind of service principal that we're going to write to. And some of the changes they've made to this are stuff like managed identity. So you've got almost all resources inside Azure. So if I look at a function, so if I look at any functions, I should be able to just make a managed identity of this. So when I deployed this, I give it a managed identity. And this resource is registered with Entra ID. Okay, so this means if I want to use this in any other resource, so if I want to talk to this on the key vault, so under my key vault, I can look for this resource. So this is just one that's done with it. So inside here, if I look at settings inside here for access configuration, we can use either RBAC or vault policies. RBAC is the preferred mechanism, just as it is in AWS now. But if I go to access policies, I'll find inside here I've got get and list on secret permissions inside my functions based on that managed identity. So we don't have service accounts or anything else now. It's just a delegated permission set. This is a much simpler way of working. It's a delegated security mechanism. All resources inside Azure can get an identity to do that with. And we can then set up RBAC or anything else you want to do with those resources. So this is a simplified mechanism. So if I don't have write access, so if I go to the settings of this function, or maybe not. So if I go to that function and I go to the environment variables, what I'm going to see is tick boxes in the actual settings here for these configurations, because they can write to the key. Well, maybe not, maybe never. But inside here, I should see nice, pretty green tick boxes that say these are talking to the key vault. And in the key vault, I'll put this up another time. Let's load some of these. In the key vault, I'm going to talk about security in the next chapter, so I'm doing this. But in our key vault, we'll actually find there is, under our secrets, any of these secrets will have a secret identifier. So if you're sniffing this across the network and you don't have rights to the key vault, you will just have this information coming back, but there's nothing you can do with it, because the secret is something else entirely. So if people are sniffing on your network and they don't have rights to see that information, they're just going to get the secret identifier that's passed across the wire. You won't be able to do anything with it. Yeah? You won't be able to see what the account key is or the formats are. And as long as these are connected to it, when you actually put these in, so this will actually say key vault, secret URI, and whatever that secret UI is. So that's reading information from a secret endpoint. The upside to that is the fact that it's encrypted, but also if you listen across the network, you're not going to be able to read that information. We can also do this where, say, I encrypt a column inside a SQL database. So if I encrypt a salary column inside a database and put that into my key vault, that would come under my keys. So one of the things I can do is encrypt a SQL column. Sorry, is that bad? See ya. It's all right, it's fine. Yeah. It's just when everyone goes and there's one guy left on his own, I can just attack. Yeah. So you can actually put this in that column. So your SQL administrator wouldn't know what the salaries are in your organizations. Okay, believe it or not, that's quite a big problem. Yeah. If they don't have rights into the key vault, they can't see this information. Downside to it is it's going to write half the speed, but if you're not changing it that often, it's all right as a format. So key vaults are something that are quite useful when we're setting this up. But the reason it's useful is because you've got a service principal, in this case, a managed identity, which is available on almost all objects inside Azure. So we're not using service accounts like we used to that change every 30 days or 42 days where you've got to reset up the passwords and do all the other formats in there. You put this as a managed identity. And if you're looking at those managed identities, so when you do an identity, there's a one-to-one relationship. So they're called system assigned. What I could do is I could create a user assigned identity and then add other resources to it. So that one identity could be used for grouping of things in here. So I've done it under a service bus with other things that are connected to that. So under that one service bus, there could be other endpoints that I want encrypted or set up in there that can actually talk to it. So they can all be done with that identity. So that relationship can be a one-to-many inside that identity. Permission types are either delegated or application. So you could set up applications that if they're delegated, will use the user's logged in identity with the union of what the application settings are. The application has got full rights for everything and the user has read-only, then read-only would be the ones that are actually in there. So again, it makes it safe for users, least permissions. And your applications can do anything they like, so be careful. Okay, and you can set these up fairly simply. Okay. And the MSAL stuff, you can say how you're going to debug that and other settings inside here from a token point of view. As we spoke about earlier. Go on.
Just one question.
Go on.
The managed identity.
Yeah.
So how is that? How does it all fit?
So really, your identity plane is how it all fits. So because it's registered in your Entra ID, if I look for any of those resources, they are going to be registered inside there. So if I put an application in there, I put a function, I use a DevOps public format. So inside here, if I was to write this, because I can use this between other systems. So if I look at Entra ID, I go to my objects. So inside here, I've got either enterprise applications or app registrations. If I look at app registrations and I look at all applications, and I have a look at something that starts with SS, these are my organizations. So this is an organization, this is a project, a unique identifier. But what that is a managed identity that will allow me to integrate with Entra ID and use resources in Azure. So if I write something in, go on, sorry.
No, I find this very interesting.
It's actually a lot simpler than we used to have to do in Windows. Yeah, I think Unix was a lot simpler as well in the way that we actually set this up for delegated settings. But the whole point of the Entra ID is flat now. So everything is just an object that's registered with our Entra ID. And then you've got an application ID. So each one of these will have, you know, an application ID for their object. But inside Entra ID itself, if we have some that aren't, you know, that are current, you know, these will have the application, but they've also got an object ID that is specific to Entra. Yeah, so this is when it's registered, this is how it references it. That's how we reference it under that tenancy with either a secret or a certificate. And that's going to give you your service principal. But it's a delegated security mechanism that's simplified. And it's actually quite cool. Because you can get almost all resources in Azure using it.
No, I mean, I've worked on Azure a couple of years ago and we used it a little bit. And then I've used HashiCorp a lot.
Yeah.
But okay, thanks.
All right. And it's even better with infrastructure as code because I can register that when I deploy it. Yeah, so lights out deployment now, this means you register, put it in the key vault. Okay. So really that's quite useful. Everyone's still awake? Yeah, yeah. Wake up after 3:30 kind of format, yeah. So this kind of thing is more the security side. So from a security side, inside the cloud, can we make the cloud secure? Why? All you hear is bad stuff, isn't it? You know? Can we can make the cloud extremely secure. What's the downside when we do?
Nobody can log in.
Everyone complains how hard it is to log in. Even when you do multi-factor authentication for developers, you should hear how many people moan that they've got to actually press a button on their phone to be able to actually use stuff, you know? So developers get upset with the kind of, you know, single sign-on kind of settings inside there. So people using this multi-factor authentication, we should put everywhere, including on-premise. So whenever you do anything, and the upside is for you, your identities aren't being stolen. No one can log in as you and do something else, you know, which was one of the issues that everyone worried about, believe it or not. If we're looking at other things, though, for security, configuration is the thing this talks about. You know, there's plenty of other areas for security, but two of the areas inside here for security are Key Vault, which is really about the life cycle of your application, and app configuration, which is really more of the enterprise kind of settings inside there. Anyone using either of these? Yeah, anyone used Key Vault or used, yeah? Found it bad, good, bad?
It was nice.
It's, yeah, it's not much to it, is it? That you just use it, yeah. One of the things I think banks hated is the fact that there wasn't more kind of hierarchy inside your Key Vault, but it's not written for that. It's for the life cycle of your projects. So the idea behind a key vault is the fact you've got secrets, keys, and certificates. So the idea behind it is if you're looking at keys, as I say, you could have something like SQL where you're encrypting a column. If you're looking at secrets, these will normally be secrets that you don't want anyone from an admin point of view or looking at web applications, functions, or things like that to be able to know. And if you're looking at secrets, we want thumbprints from this as a central repository that also rotate into other systems. So it is not a centralized system. It says centralized up there. It's not. It's per application or lifecycle. Okay? If you're looking at app configuration, so if we look at app configuration will allow us to have 10,000 Unicode characters. Okay, so I can import stuff into this location. So if I go into my operations, I could import a load of information from different settings. I could also look at my configuration manager, and one of the things I can do inside here is point these to something like a key vault. So I can set this up, but this actual naming mechanism, you know, blas::settings.secret key, whatever, I can use up to 10,000 Unicode characters, have colons in different sections in that, as well as a label for what environment I want to run this in. So this is an enterprise way that I can actually specify where I want that information coming from. And if I do want to use key vault, you know, I can put that in a key vault. So I can put that in a key vault as well. But these are going to be Unicode characters that are going to have to be unique, based normally on a project, so whatever your project name is, and maybe some other configuration settings. But they're going to be a hierarchical way that you could do that. If you're looking at key vault, you know, if I have more settings in there that use the same name, I'm kind of screwed. What am I going to do? Make a new name up every time I put this in? Because that's the problem with the key vault. The key vault is really application scope. I don't have any labels or other things to do this with. If I want to change it, I can put a new version in here. So I can create a new version and get rid of the old one. But this is essentially the way that I would change values inside Key Vault. So Key Vault is really securing secrets for your applications. Okay. So best practices here, manage identities. If you're looking at legacy stuff, a service principal and a secret. But again, if you're looking at anything that's going to production, you're going to use a certificate with that normally. Secrets are just for development. They do recommend, as I say, vaults per application, so the life cycle of the application, and you do other settings in there. So you can use it, and there's a variety of ways you can use this. You can use this on premise, yeah, so you can secure settings. So how do we configure configuration at the moment? And why does configuration matter? If I want to attack your company, what will configuration normally give me? Why do attackers think in maps and administrators think in lists? Anyone been online and they've had an error come up and they've got a full stack trace from what they've actually connected to? The number of times I've done that and I've seen exactly what the error is, it's told me what SQL is on there, what format is, what version it is, when they've actually done that. Is that a good idea? Do you think that's an insecure mechanism? Well, hopefully everyone says insecure. Yeah, let's say it's insecure. One of the things that gives me is a way to attack that environment. I know what those settings are. You know, so if you're doing exception handling and you're passing information back, unless it's APIs, we're going to try and be a lot more rigid on how we pass that information back. And even when we do APIs, we're going to limit the actual information that's coming back normally. So that's one thing. The other side to this is if I can get to configuration information, I normally know where things are as well. You know, if I use phishing and other things to attack your systems, I've got some way to actually look at that. If you look at BEAS, social engineering toolkits, there's plenty of things in there that will allow you to attack systems quite easily. You don't script kiddies can do it. You don't have to be intelligent to do this. And that's the problem we've got. So how do we actually hide our configuration? Does anyone use user management or encrypt their configuration settings when they set them up in the first place? I think it depends what environment you work in. But governments normally, well, you'd have to do that, don't you? Yeah, from a configuration point of view. Anyway, so configuration information there is normally dangerous. And that's really what this is talking about. So we can use our configuration settings and secure them to the Key Vault. And if we want to have a look at this, where we're looking at app configuration, this is more a centrally managed or enterprise managed kind of format that gives us one other thing. So this does allow us to look at feature manager. So if anyone does launch darkly or something like that, you can actually create, feature flags or other formats that you can use out there and don't have to redeploy. You can just turn things on or off. And if they're not part of your organization or they don't have permission sets, you can give them other features by turning them on or off. So this does have feature flags as well that you can set up. So you could create feature flags or look at other systems in here. You're going to put this under the app config or some configuration setting and then deploy that. You can get telemetry or experimental formats as well. Okay. So that's some of the advantages of looking at something like app config. I'm not going to spend a lot of time on it because bore you to death, but it does work with a lot of stacks and frameworks. So if we're looking at event-based solutions, okay, so this is something we were talking about earlier with functions. So one of the things you've got inside here is event hubs and event grids. Okay, so from a point of using functions, one of the things we can do is using the event grid, which will allow us to route or filter to that endpoint. So if we're using something like the event grid, I can route the events to endpoints. So if I want to use a function and have that as an endpoint, those event handlers we can redirect to. So if I change something in storage, so I put a new file in Blob Storage, that trigger, we can use that with our serverless code and change the endpoint and then make some changes inside there. So you can write this to filter and to route to specific endpoints or other systems inside here. So event gives us that functionality. If we're looking at event hubs are my more Kafka-based, but they can be used for really, I'm going to jump through these. These are used for really grabbing events as they happen. They can go through real-time kind of formats inside here, so you can get a lot of events inside here, and then you could redirect them. So you can capture event hubs. So if you write event hubs, you can just create an event hub. And one of the things you can do in here is just capture and put that to your storage account or to a data lake. So you can do that. And in here, you can go up to 32 different partition counts, which means you can get through more throughput. Anyone using Kafka or come across Kafka in your environment? Yeah. How have you found it? Excellent. Kafka's fantastic for event sourcing and doing other things inside there. Yeah. This is their version of Kafka. They mirror it, but they do mirroring Kafka as well inside there. So they can point all this stuff to it. The other side to event hubs, though, is inside your event hubs, you can use these with, say, application insights. So if I look at application insights, I want to see something that happened 8 days ago. So in here, if I have something that is $30 days old, I might not have anything that's 30 days old, but not even seeing the one that I want. Maybe I deleted it. Maybe I didn't. So if I want to look at this information, so I'm monitoring or investigating, I should say, and I'm looking at this information, and I passed through things earlier on. So this went into a Cosmos database. But if I look at this 30 days ago, one of the things I can do inside here is I can use an event hub and I can look at this, what happened 30 days ago. And I can look at the failures and other settings inside here. And I can look at what happened, what exceptions I had, and these can come up with the timings. So this was the 20th. That's not 30 days ago kind of thing. But this will give me those kind of things that I can look at. So the event hub is storing all those events as they happen for me. I can see these from a runtime kind of point of view as they go through. So this gives me a way to monitoring that information. I can also, though, use stuff like cognitive services. So I can look at this for, let's have a look at anomaly detectors. So one of the things inside here I can use is I could put Grafana through this, or I could put some other mechanism like event sources through this and let it actually look at proactively what's going to happen in the future. So anomaly detectors and other formats can also be used in here with event sources, in this case, event hubs. So those have got some use inside here. If we're looking at service-oriented architecture, we've got service bus and event and storage accounts inside Azure. So we can use this for our service bus. So inside here, again, I'm covering these fairly quickly, but you can have a look at service bus. Yeah, so inside here, we've got service bus. So I have a service bus, it's standard, but I've got a lot of queues in here. So if I look at, say, something like my event queue, this event queue is going to have a load of messages inside here. So I get dead letter messages. So anything that's older than 2 weeks old is going to be able to either peek in here or receive mode. And I can receive those messages. Say I want 1,000 messages. Yeah. I can have a look at these messages. So it'll give me a load of messages inside here that I can look at. And these are the same messages that went through when I was passing them to my Cosmos database. So these are what we're reading inside my Cosmos database. And they've just sent this to a service bus. So I've just put this as another endpoint. So service bus is a queuing mechanism. If I create a queue, so if I create a queue, this will give me a queue standard up to 5 gig. I can run this for message to live 2 weeks and 1 minute. I can set auto delete on idle queues, check if there's duplicates, enable dead lettering in this case if they don't get picked up. I can also do sessions, so I can do inter-session kind of formats within here. So one of the things we can do with this environment is interleave our messages inside there as well, or put them into a topic. And a topic is just a publish subscribe model. So that can actually be done inside there. So this is a more brokered message system.
Question.
Go on.
Can we connect to it like it was RabbitMQ?
And you connect to it?
Like MQ, for instance.
Yeah, yeah.
Does it have its own client libraries or
Yep.
does it implement them?
This was the extension to that. MSMQ was really the early version. So we're talking about MSMQ on-premise. Are you looking at Microsoft message queuing, or are you looking at advanced message queuing protocol? Or
a lot of applications have messaging.
Yeah.
We could use Kafka, or we could choose something simpler like RabbitMQ.
Yeah.
The question is, can we use this?
Yes.
And what would it look like from the application? Does it have its own client libraries?
Yep. So service bus. Yeah, it's got its own SDK. So it's got a full SDK, and you want this in Java, actually, don't you? Yeah. So you're just going to have create queue, and then the normal message formats that you would normally have inside here. Yeah. So the normal thing, and then you've got queue, DQ. You can set up other settings inside there. But it's exactly the same as you've got with stuff like Rabbit. I didn't hear the Rabbit bit. I didn't hear that, sorry. So yeah, with RabbitMQ and other formats, yeah, they work the same way. All right. So a lot of these are going to work with the same kind of messaging. You're queuing. The two modes you've really got, though, is peak. So the modes that you've got inside here when you're using these in Service Bus are going to be your peak and lock. And then you've got stuff like your, so underneath these formats, your modes are going to be peak and receive mode. So you've got your peak and lock, and then your receive and delete. Or you've also got abandon and other formats in there the same formats you've had with Rabbit and other things. Yeah. So you do have those two mechanisms in there, and your transaction IDs, or your message IDs, and you've also got transaction formats in there as well. But most of those things are going to be the same. Yeah. This is a brokered message system. Service buses. If we're looking at queues for, say, storage, they are not. They are like a conveyor belt. They are a backlog system. They're not really queues. You know, the messages in here are immutable. The messages inside your storage are not. They're 64K as a maximum. I can put 100 meg message inside a service bus. So it can go up to 100 meg in size. Yeah, but if I do that, when I create this service bus, I'm going to have to create dedicated. So if I look at the plans for this, standard that I'm using is going to cost me £10. If I'm going to use premium, which is dedicated, to get up to 100 meg, that's going to cost me nearly £700. There's a big difference in dedicated formats. I also get 13 million messages free for the £10. Yeah, so overall, if I'm testing stuff, this is shared capacity. If I'm using anything like data factories or data gateways, then you're going to go for the dedicated version, and you're going to be using encrypted, and they have an event-based system inside there as well. All right, but this is really what you would go for, zone redundancy and everything else if you're looking at a queuing system. Okay. So inside here, the real thing they talk about is the difference between, say, your service bus queues and your storage-based queues. The storage-based queues will go up to 4.77 terabytes. Your service bus will go up to a maximum of 80 gig. So it's a maximum of 80 gig, and the message size is 100 meg. I know it says 256 there, but it's 100 meg if you go dedicated. Service bus is also first in, first out guaranteed, one recipient. And we do have long-running parallel streams if you're using sessions. So premium is going to give you up to 100 megabit or megabyte. Okay. Trying to finish this so you're not too dead. Okay, and so the only other thing really that this talks about, it does talk about static websites, and looking at, say, your CDNs, so content delivery networks, where we can use this with static websites and push this to endpoints. So your content delivery network, where you can use storage, and we do have, as I say, WAFs and things like that if you're using CDNs. So you have got WAFs. So you've got CDN WAFs and things like that as well that you could set up. And you can set up what your endpoints are going to be. So you can associate those CDN endpoints and use them. So these are static websites. We can use storage. We can put it on the content delivery network. And hopefully, if we're using their system, they're going to deploy it to all the edge servers. So what's the downside to this? Just to keep everyone awake, what's the downside to putting everything on an edge server? What's the thing everyone wants in Norway, as we spoke about? If you're looking at, say, a lot of the government formats, they're doing it. Where do they want the data?
In this country.
Only in this country. It's a sensible operation, yeah? No matter what happens anywhere else, you want your actual data kept in this country, you know? The number of times we have people replicating data at other locations, you know, so the idea is we're hosting it, we put it here. This problem is this is going to write it to 60 edge servers for you, okay, by default. So this goes to all those edge servers. So if I put anything on CDN, like my Blazor stuff, that's all gone to 60 edge. So that's globally anywhere. That's not a good way of working for a lot of companies. So that's the downside to that. If we're looking at application insights, though, so this is really instrumentation. What's the upside for us to have a system where metrics are already done for us? If I want to connect something together, so I've got a function here, and I want to connect multiple things to it, You know, if I go to monitoring and I click on application insights and I say, I want to actually change that data source. So say it's connected to itself, I can push this to other data sources. So I can have multiple things in my configuration that are going to reference my data. So if I want to have a look at 5 functions that are running, and they're all running in the context of this application insights, I can see everything they connect to, where information comes from, any 401 errors, any 400 errors, any 500 errors, exceptions, other traffic that's coming across there. This will actually look at all of this information for me. I put 2 functions in this, and I saw both functions. I saw Cosmos, I saw the storage account, those kind of things are put in for me. So all the instrumentation allowed me to view that. If we didn't have this, how would we have done that? Does anyone use AppDog or other, you know, App Dynamics or other tools inside there to do this? Anyone? Yeah.
Datadog.
Yeah, so Datadog. So in that case, have you got agents or are you just connecting everything? Is this on premise?
No,
It's in the cloud. Is that because of licensing? Because normally I'm finding, yeah, because Datadog normally, you know, it's quite an expensive product. A lot of the time it's actually cheaper if you're using licensing on premise. So that's why some of the people use the same, but it's also the same content in both areas. So, but if you're looking at your metrics inside there, it gives you that functionality. 10 years ago, we used to write our own instrumentation with all the hooks and everything. That was a kiss of death. You know, we've got a system now where I click a box and I've got most of this functionality put into that. And if I'm looking at slow pages, Ajax failures, all these kind of things can be put inside here. So when you're looking at your information in here, you can actually look at your other settings with performance and those kind of things. But if we look at an actual endpoint, so if I look at whatever this is, let's have a look at this. So if I look at this data and I go down a bit for usage, this will allow me to look at usage information, session information, following events, event flows. So anything where we're designing some front end, I can see how that's being used. Where do they go to most often? You know, what are the events actually figured out in there? What are the user flows? So what events fire off those? I can select an event and then see where people are doing those changes. So you can see utilization in there. Yeah, as well as the other things where we're looking at, you know, availability, failures, and performances. So we can look at all those things as well. But you can interrogate that as well. So you can look at those low-level stuff. So you can do those things inside there. So from an Azure point of view, they do give you a lot of that functionality, but this is coming up simply because that instrumentation key is being used inside here. So I'm referencing a function with that instrumentation key or a web application with that instrumentation key, and I'm seeing that all that stuff coming up in there because I've referenced it. I can then use that to get the rest of the information. If I'm getting slow page loads, as I say, Ajax failures, you can see all that information, exceptions. If I delete a container out of Cosmos, it comes up and tells me I've deleted that container. It actually tells me what the problem is. If I can't make a connection to a data source, it tells me that's the problem. So when I first set this up, I didn't put in a correct data source. So on the failures here, it actually came up and said, you know, when I did this, besides you are stupid, it did come up and say, you know, what are the main exceptions you've got inside here? What's the argument exceptions? We have quite a few. So a lot of these coming up with exactly the same thing. And it says format of the initialization string does not conform to specifications starting at index 0. That is a big code to say you've got a connection string wrong. That's the error that comes up when you don't have the correct connection string. So if you've seen that normally, you know what that actually is. It's telling me I screwed up the connection string. You know, if I delete a container, it actually says you've got rid of this container name. So we actually do get a lot of help with this information. And we can see that information coming down. So all the event stuff is coming in here. All right. I'm going to stop boring you now. Yeah. Because I think that's enough. I think everyone's face is like, will you shut up? Yeah, so. Anyone got any questions on this stuff? Or you just bored over now? Yeah, I've had enough. By the way, I go to Microsoft seminars and fall asleep on the front row. Yeah, they bore me to death. Yeah, so some guy waffling to me also is the same. Yeah, I understand. Yeah, it's quite hard to stay awake. You've been very kind, thanks. Didn't laugh too hard if I nearly killed myself. Go on, sorry.
If you haven't used Azure much or not at all, how do you recommend to start to learn about?
Are we talking about programming? Are we talking about the environment? What are we talking about?
We're talking about programming what the hosts in.
Okay, so from an application point of view, really hosting. So one of the things that Microsoft do is 5-minute tutorials. So you can go through a 5-minute tutorial and see how some of that go together. If you're having a look at specific areas, you know, they'll do a lot of snippets. So again, you can grab the snippets, see if they work, and then change them and break them. That kind of thing tells you quite a lot normally when you start out. From a point of view of how things fit together, that's more of a difficult kind of thing, you know, like all of them. So if you want to see how, you know, if you looked at Service Bus is actually quite a nice tool where you're going to drop something as a message, but what's that message format? How is that? So that can be more of the problem at the start. But from a point of view of really starting out programming, quickest thing is to really have quick tutorials, see what actually is in there and decide to write, you know, like all things, the more you use it, the better, the happier you normally are in there. So if you wanted to, you know, do something that is of interest to you, that normally works better. Yeah, it might not be business oriented, but it's something that interests you. The downside is, do you have time? Are you allowed to play with Azure? Do you have some time? Do they give you some functionality to play with? That's the biggest problem normally with Azure, is you're not allowed to actually touch it. You're spending money, you know, so how do you set that up? So normally starting this off is one of the issues. If you've got a credit card, you can get 200 euros or 200, it might be 200 million, not, I don't know, but they'll give you something inside here where you can play with it. But the big problem is normally how do you play with it? Because it's normally going to cost money. So that's normally one of the issues. If you've got a credit card, they'll give you some free time to play with it. So if your company doesn't do it, you can just use a credit card, but that ID is then dead, but they'll give it you for 30 days or $200, I think, whatever that format is here. So you can play with it. So you can play, go on, sorry.
You talked more about cost on different parts.
Yeah.
Is there a way to, if you have plans to develop an application?
Proof of concept. Proof of concept. The only thing I'd use is proof of concept.
Yeah.
Because
if you're constructing
yeah. So
not an application and you're going to use it, is there a way to find out in advance how much this will cost?
okay, so there's a calculator, which is useless. Yeah. And the reason I say it's useless is because they will give you costings. So if you look at the calculator, but if I'm doing work for other people, I would always say that we're going to run a proof of concept on you putting a credit card in and giving us $200 or whatever it is, and we'll run that kind of format. You're going to pay for time, but we're not going to say this is the cost of things. So if you say, right, web app, so we say a web app, you want, you know, some kind of service app. All right, we'll change your name, whatever you're going to do. So now you say app service. Okay, sorry. So if you say you want to look at an app service, you know, inside the app service, you're going to say where you're going to run this. I'm going to put Norway East. I'm going to run it on Linux. Tier is going to be, you know, premium. It's going to give us a cost there based on that static cost. You know, great. Do we integrate with other systems? Yes. What are the small compute costs? There's loads of things that suddenly bite you when you're doing those costs. So when you say, can we cost it? Yes, you can put all these things together, but they don't really give you any real cost. And you've really got to think about, I mean, I know everyone says they don't really worry about costs in this room, but if I'm dealing with a company, they are normally very, very aware of what those costs are. You know, so the reason I preach so much about costs is because You know, if you tell somebody it's going to cost something, I would never say it's going to cost that amount anymore unless we've done a proof of concept. So proof of concept's the only way I really know to get any costs out of this, really. Yeah, I can give you a load of calculations and say, this is what the calculator says. But if you give me the wrong capacity or other things, well, that is just wrong. So I would advise you, proof of concept is normally the best way to go. Go on, sorry.
Yeah, so more about costs. Is there any major cost traps with Azure? Something you can do that?
Lift and shift is the biggest one I've seen that companies just don't seem to grasp. You know, they do move stuff and treat the cloud as if it's an on-premise kind of mechanism, and you can't. You don't ever want any user any cloud as if it's an on-premise environment. It's a rental model. It's like going to rent your car. You don't have, there are totally different ways that you work with that, and you've got to re-architect to do that. So re-architecture is one of the biggest problems, and re-architecting costs money, design, thinking. Nobody likes to think, so you've got to think about those problems and what's going to go wrong. Yeah, so I think it's a big argument. But you've got a lot of companies 2 years later saying, we didn't think the cloud was going to cost us 2 to 3 times what it was costing us before. Why not? It would do. You're using it exactly the same as you do on premise, which is a bad idea. You know, if I write something in here, and I've got a lot of services. So if I look at a chat system, yeah, so I got inside here. So I can use Signal IR inside here as a service. I'm not running a host to do this. I'm not running I can run this fairly cheaply. I'm not putting a server in the cloud as I would do on premise if I'm doing this kind of stuff. But people that run this, you know, when they lift and shift, still do that same kind of mechanism. They're not aware of the services that they can just get to if they go to the cloud. Yeah. So those are the biggest costs I've seen from a real point of view. The downside is knowledge for what's cheaper. And as I say, the best thing to do is a proof of concept if you are going to look at making things cheaper or re-architect, seeing what the re-architecting actually does. But you will spend a lot of time and sweat doing that. And financial people always give you a pushback. If I say I wanted to do something serverless and they say that what the cost is and you say, I don't know, they're like, well, we don't want that. We want to know exact costs that's going to be in there. So we want estimated costs, and we'd rather pay for, you know, app services that run all the time because we know what that cost is and can offset that, than if you tell me something is serverless and we don't know what the cost is.
Yeah, in the last the session before the break, you said something about there was something which was much more expensive than Azure.
Yeah.
Something about API gateways.
API, yeah, so API management services.
This is like, for example, in Google Cloud, you have like this AppG, like the corresponding thing.
I'd have to check off the top of my head. The reason I'm saying that this is expensive is if you look at the pricing. So the pricing for API management, you know, and they are changing the pricing of this. So they are changing the pricing of this. But if you look at this from a dedicated point of view, so you look at premium for this, you look at the money, so that's $2,795 for premium. This will give you total throughput, it's API management, it's on all the time, it's a gateway, it's other settings, they integrate with other services. So there's some things in there, but nearly $3,000 for what, you know, it's a big difference for, say, using that in other services, like in Google or in AWS. But that's the biggest thing I've seen as a big cost. Yeah. And it's just that number, you know, and I've got a couple of companies that had 3 of these, you know, and they were just, you know, I know you all say you don't worry about costs, but, you know, if something's costing you $3,000 and you're using 200 APIs on it, that seems a lot of money. Yeah. It does do authentication, it does do the gateway. You've got the ability to change things dynamically with policies. So there are some things in there, but I'm just not sure that cost difference is something to aware of. Go on. Hey, at least question. Go on, sorry.
What would be the alternative?
So, but the alternative, you just host some web applications. Yeah, I just create 200 web applications. Yeah, this might be cost effective. I've got thousands, But I've got 200 web applications and they're spending that amount of money for this. Yeah. I can get those web applications, host them, change what their names are, and redeploy them. You know, I'm not dynamically changing with policies. I don't have a gateway inside there. I'd have to pay for an application gateway. You know, that could cost me money.
Yeah, but then I would have to do all the authentication.
So then you would have to think, well, API gateway will do, sorry, the actual application gateway would do that from an authentication point of view. It's a VM that you set up and you put a WAF on it. So you could set that up. But security is always expensive in the cloud. It's one of their biggest costs, is security, because everyone is worried about security. Yeah. I mean, my biggest resource at the moment is the cloud service. So, sorry, the cloud, whatever they're calling it this week, the cloud kind of format. So they're putting all of the cloud stuff, like Defender for the Cloud. You know, when I look at Defender for the Cloud, if I do anything with DevOps inside here, so when I set this up, any security, any of the cloud security, any of the management stuff, if I do DevOps security, for doing nothing, that's going to cost me £150 a month. I only get 115 on that subscription, developer subscription, to play with it. I had to turn all this off because I didn't do anything with it, and I still ran out of money. It's monitoring all the time. Yeah. So from a company point of view, that's something you're going to, sorry, go on.
It's a different topic, so.
Go on, that's fine.
Could you explain a bit more about like the premium and the tiers and the? I'm not familiar with those from AWS or Google Cloud.
So is this to do with the service, the API service?
Yeah, for example, is the standard one way cheaper? Or?
So if you look at, say, something like Service Bus, you know, standard gives me queues and topics, and I get 13 million messages a month, and I use standard. I then have to write some event-based systems if I'm going to look at grabbing information from functions. I'd have to write that. Whereas in premium, you get up to 100 meg messages. You get other functionality. It's dedicated. So a lot of the things, when they make them standard, then they're shared environments. Whereas dedicated, they're just set up hardware for you, which is why you're going to be paying more money. Yeah, so those kind of things are going to be one of the things that will pay more money. Yeah. So from a different premium kind of things, you could find this huge advantages though. So in Service Bus, if I was creating a data factory or I'm creating a data gateway, that would always be premium. I'm encrypting everything that's going from on-premise into the cloud. That has to be a premium version to do that. Yeah. So it depends what you're going to be using it for. If I'm going to do some testing for messages, you know, standard is going to be fine for £10. All right. So it does depend what you're using it for.
So basically, the standard premium is different in functionality as well.
Yes. Yeah. So throughput, amount of information coming through, all of that kind of thing is huge. Yes. Sizes, all the resources they're giving you. Yes, that will always be true. Yeah, when you're paying for premium. Off normally, yeah.
Getting back to Eva's original question, I think this is perhaps one of the risks with doing a proof of concept.
Right. You don't use.
When you go into a proof of concept,
yeah.
You don't necessarily think of all of the security aspects.
Yeah.
This will be cheap.
Or you do go into the security concepts even then. Yeah. So I take the argument, but really a lot of the proof concept you have problems with is they don't tell you really what the capacity is. So that would be one of the arguments. They don't tell you that we do need a secure, and it's got to be back in a certain period of time, because that's the other argument. You know, so if we have non-functional requirements that come back and bite us, then that's one of the issues you've got to think about. I agree. Yeah, so non-functional requirements are something that will bite us if we don't actually think of that at the proof concept.
This is one of my biggest
agreed.
annoyances with Azure, because I normally want to keep things away from the internet. And as soon as you want to keep things...
Security is going to be...
VNet connectivity, then everything's on premium and it costs...
a lot more money. And security is the big thing in all cloud providers that costs you money. They make money out of you. Application gateway costs me 25 quid a day. So that's normally what they'll cost me. If I use front door security, that costs me 30 quid a month. If I look at something like a WAF or a CDN, that costs me £10 a month. There's a big difference in how much of that cost is going to go through. And Microsoft will always advise you to use application gateway. Go on, sorry.
Yeah, and I guess if you're using that, you should move to AWS because it's like £2 a month for the.
That's it, those kind of things, yeah. Well, no, it's true. You know, that's the kind of thing. And they will do other things that will burn you in how much work you've got to do to get around that. But yes, you know. And the only people that are going to bring those costs down are the other cloud providers, because the public clouds are going to kill private clouds, you know, just because the storage is so cheap, you know. And remember, it costs you nothing to put stuff into Azure. It costs you money to take stuff out. But all design is keeping stuff in Azure. So if you do use backups or other things, you put stuff into Azure. It costs you nothing. As soon as you want to grab that out, say big data, I want to analyze this stuff and bring it out, that's going to cost you a tremendous amount of money. So your design has to think about that. Go on.
A bit back to storage and taking it out. You
Yeah.
have those hot, cool, cold.
Yeah.
Is it also like more expensive to get these out from?
So the cheapest is going to be archive to store, but to get that back, that could take an hour to get back. You know, so if you want to take that back out of from an archive environment to your runtime environment, it's going to cost you money. And it's going to be slower unless you pay extra to get it out faster.
And you pay for it, right?
Yep.
Yeah.
There is nothing free in the cloud. Get used to it. Nothing is free.
The first 100,000 functions.
Million functions, yeah, they're free. But remember that you've got to work around how that's going to be done. So yeah, in there.
You need the API gateway.
There, you know, you need to share that. Yeah, you're going to run that on your service API.
So basically, your recommendation, if you want to use just API gateway with function, just don't use Azure.
You can use the other version. You can use the other versions. There's one for about £500, and there's some. The developer is £45 a month. That kind of stuff. So you could run those and you could test them. But if you think about security or other things around that, you've got to look at which version you're going to have to use, and again, the cost that's going to be. But I was just surprised if you look at other cloud providers how big a difference that was. You know, they are coming out with different versions, but that was one of the big things. You know, some of the other things are cheaper in here, you know, than they are in Lambda if you look at AWS. But the one that always bought, you know, that was the one that was a big shock when I looked at it from other costs. Yeah. I mean, I know you don't worry about costs, but it's one of the things that, you know, you don't. No, from what I've understood, nobody cares for costs. You just run it.
Where I work, we have been in Azure Cloud for more than 2 years now.
Right.
And they're drastically changing parts of the
Oh, yeah.
now because of cost.
Yeah, it makes a big impact. Yeah, how you re-architect things is a huge impact. Yeah. I mean, go on, sorry.
Yeah, I didn't, this plan, can you change that for different components, or is it like the one overall plan for the whole?
So for Azure, there's a number of ways you can actually get into Azure. So if you're looking at enterprise agreement, you can have cost centers and other things, but that's the enterprise agreement. If you were looking at licensing or you want pay as you go or other things, there's going to be different costs on that. But if we're looking at service resources and certain plans on resources, they're going to be different for the different resources you use in Azure. Yeah, so you're going to find, as I say, functions is a different mechanism to VMs. You know, they work differently on how that, what the resources are and how they're costed.
If I don't use it, I don't pay for it.
So in a VM, say, if you switch a VM off, you're not going to pay for the runtime stuff, but you're still going to pay for the storage. Yeah, because it's a VM, you're using their storage. It's just not going to pay for a runtime to use that. So each one of these have their other quirks that are going to bite you in some respect.
But you can still sort of tweak on that.
Yeah, you could turn off, you could delete your VMs every day. You've got something called spot instances, believe it or not. When they're not used, they'll delete. So if I was doing batch processing, one of the things you can use is spot instances because they stay alive while they're being used. So you could have thousands of spot instances, and it's used a lot with, say, batch processing. They all come up, and they'll cost you pennies to use. But as soon as that's finished processing, then Azure's going to delete it, and it's no longer there. So there's a lot of different things inside Azure you can do to make things a lot cheaper. But again, it's knowledge and being able to do those over time. Yeah, but if all you do is lift and shift, it's not going to be cheaper. Yeah. And from an application point of view,
you can make some really good decisions and some really poor ones. Yeah, like everything else. And really going back to, you know, non-functional requirements can really bite you. Yeah, if you don't have a lot of them in the first place. Everyone all right now, or any questions?
Yeah.
Stayed awake?
What about command line applications? Like, do you have some kind of administration tool that you can run?
The command line, are we looking at, say, cloud service, or are you having a look about running things from command line?
Yeah, because sometimes it's quite handy to just run a small command and then get an overview of.
Okay, so inside the portal, you've got a full CLI environment. Yeah. So this is a full CLI environment inside here. Let's see if it is. It might die on me. I had a problem the other day where it deleted. So, but anyway, so inside here, you've got really everything but root in there. You've got Bash or PowerShell as a CLI version in there. You can upload stuff to it. It's got about 50 gig, so you can play around with this. In this case, it's very much like Unix. So you've got all your stuff inside here, so you can upload stuff. So if I'm foreign countries, you know, you can set this up and deploy stuff. There's Ansible in here. So you can run, you don't have to authenticate yourself, you're already in. So you've got Ansible, you've got Node, you've got Python. You've got loads of stuff that's actually built into this. If you're looking at from a file system point of view, you've got, and this is a Mac compared to Windows, you've got command line. You would have to log into the environment. So if I was doing this in Windows, then I would have command line inside here, or not the case may be, its session has been killed. So if I'm looking at this with, say, a Mac, I've got my terminal, so I can do AZ login inside here. If I set this up, I've also got PowerShell. You know, if I switch between this and PowerShell inside this, so I can run commands in here and run them. You know, you can run them inside your environment under this. So command line utilities are used quite a lot.
Yeah, but what about from your laptop, for instance? Let's say you have some kind of issue with one of your services and you want to inspect how it is configured or something like that, and you have lots of...
Yeah, so depending on what your service is, if, say, you were looking at, say, something like VMs, there's going to be serial tools and other things inside there that you can talk to. So there's diagnostic kind of formats, and you're also going to have other automation mechanisms inside there. But there should be something like your, there should be some other settings inside here, like you've got diagnostic settings, but I also expect serial configuration and things like that. So you've got, it depends if you've set this up, but I think you've also got serial connectivity. So you've got administration managers and other things where you can connect. If this is a Linux box, you've got secure shell. If you're looking at, say, applications, a lot of the tools are built in there. So if you were looking at applications, they've got kudu and other settings in there where you can interrogate them. So if you were looking at other settings inside here for advanced tools, so you've got, it's a Linux box, so you've got secure shell, but you've also got stuff like your environment variables, you've got bash shells, you've got your logs, so environment, secure shell, bash, log streaming, those kind of things. So you can look at most of those tools the same way for how they're being run.
I think the question being asked was actually more, instead of going in through the portal to investigate configurations of things, can it be done through the...
So all of those kind of things are available for the command line tools. So if you're used to running AZ, you can look at those, and there will be command line tools for that as well. If you're looking at PowerShell, you're more happy with that. I'm not, then you could also use those tools. Is there another hand up? Is there another question? No? Everyone had enough?
Yeah, one more question.
Good.
I guess you have some of those command line tools to both authenticate and to
Yep.
which you can use to deploy new configurations and things like that?
Yeah, you can also put certificates locally and do those kind of things. So you can run it through that as well. But yes, you can do all of those kind of things locally.
And
You've
how
al-
can you run locally testing?
Depends what the resources are.
Yeah.
So some of those inside Windows, you've got storage, and you've Azure Storage and also Azure Compute. So those are two things you can check locally. You've also got a Cosmos DB checker locally. And if you're running functions, you've got debuggers locally as well on functions. So some of those have tools that you can run locally. Yeah. They still need a connection normally to your endpoints or things that you're actually calling in there. So yes, they would still need to be able to talk to those.
Yeah, but you could debug it.
But you can debug it. Yeah. Yeah. So for most of those. Yeah.
Earlier, you said that infrastructure as code could be really expensive. What did you mean by that? Or did I mean?
Infrastructure as code.
Yeah,
Infrastructure or infrastructure as code.
You said infrastructure as code.
So infrastructure could be expensive because you're going to play with the administration of it and you've got to look after it. So if I build VMs, they're going to be more expensive. Infrastructure as code normally, the only way that would be more expensive is if there's licensing issues. So if I'm working in a team, say in Terraform, there's over 5 people, that would cost us some kind of cost there. But most of the times, infrastructure as code isn't going to cost me any money, and it's going to deploy faster, and it's an automated process. So infrastructure as code normally isn't going to cost us any money. Infrastructure is.
So what you meant was that
It,
if you buy the access to configure the infrastructure yourself, it gets more expensive.
So infrastructure as code is always going to be more expensive because if I'm running VMs, running networks, they're always going to, networks are always going to have to be there. So I'm going to be paying for that. If I'm looking at VMs, the only way I can save money on that is if I turn them off. Yeah, because I'm only going to be paying commute costs, not run costs. If I run stuff like apps, they're always running, so they're always going to cost me money. Yeah, so infrastructure as code shouldn't cost us any money. It doesn't cost me any money that I know of. Yeah, it's 5 times faster. I can use it with DevOps. I can do lights out deployment. It can configure most of the settings without people being there. So I like infrastructure as code, and it doesn't cost me any money, but infrastructure does. All right, sorry, I obviously misspoke. All right. Everyone had enough? Dun, dun, dun. Yeah? Okay.
Thank you.
All right. Cheers.